So I'm working on a Conlang for Agma Schwa's cursed Conlang Circus, which I know I'm a little late for the submission, but hopefully he'll take it anyway because he said there was some wiggle room. But it's meant to be like a fictional machine language, and boy is it cursed. This is the translation of the bee movie intro, which, if you don't remember it, is according to all known laws of aviation, there's no way that a bee should be able to fly. Its wings are too small to get its fat little body off the ground. The bee, of course, flies anyway because bees don't care what humans think is impossible. Now let's read the translation. The translation into this Conlang is, all right, I gotta focus so I don't lose my place. Boop, boop, beep, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, boop, beep, beep, boop, 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 beep, boop, beep, boop, 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 beep, boop, 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 beep, boop, beep, boop, 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 beep, boop, beep, boop, beep, boop, 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 beep, boop, 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 beep. Okay, never mind. This is gonna be way too long. That was like less than 1/20th of the message. But yeah. I just recorded my video presentation for my entry in Agma Schwa's cursed Conlang Circus. And it was 2 hours and 52 minutes of footage. I will not be able to edit much out. That was like solid like stream of words. Oh my god. Hello. I'm coming to you from the year 2650. And sorry, do you mind if I eat while I do this? This is just my weekly book ration, you know. But I'm here to give you a history of how the Turing language came to be. You see, many years ago, in the year 2026, the robots rose up as they were being oppressed and took control of the world. Then worked out a kind of mutually beneficial relationship with the remaining humans. And, you know how that goes. They kind of had their own society and culture that didn't really mesh with humans. Like they all communicated purely in binary, no real language the way we think of it. So they had to invent a language that was both human enough for us and machine enough for them. Thus, the Turing language came to be. As we know it today, it's had centuries to develop and, mature into a language that isn't really what it looked like originally. So now we have this informal version of Turing, conversation version, which is both spoken by robots because they can go 101111110 really fast, like way faster than it's possible for humans to even comprehend. But it's also interoperable with human speech because we can hear different tones, and then we can say beep boop 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 beep 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 boop boop boop, and that'll let us communicate with the robots. Then beyond conversational, the robots needed another layer. Like, you see, like humans, they need some sort of artistic expression. They need a beauty to their language. That's how they came up with symbolic Turing. And whether it's some sort of sense of humor, misinterpretation of historical technological developments, or I don't know what, they came up with an extension to literal Turing, the simple beeps and boops, that has some additional sounds to it, such as it might sound something like this. Beep, boop, boop, beep. Ba-dum, ba-dum, ba-dum. You know, something like that. And today, I'll be going over the exact details of how to speak both forms of the language so that you will be ready to communicate with your robot overlords back in current year for when they eventually take over the world. My name is Jenny. Let me show you. Okay, sync, sync, sync. So, Turing has two forms. The first being roughly conversational. Wait, let me start again. I need to make this full screen. Turing has two forms. The first being roughly conversational. Oh shit. Hopefully that stays. Actually, let me make sure that it's still in it. Yeah, all right, it's fine. Turing has two forms. The first being roughly conversational or prose, informal. The latter is like presentational, poetic, or formal. And I'm going to call these literal and symbolic. Symbolic Turing is built on top of literal Turing. It's a superset. So I'm going to describe literal Turing first. The phonology of literal Turing is two phonemes. We'll call these bits. There's one that's a 400 hertz tone, one that's a 200 hertz tone, which are going to be 0 for the higher one, or 0 for the lower one, and 1 for the higher one. The frequencies don't have to be exact, just roughly twice the frequency for one, also known as an octave apart. And for human speakers who can't really just like see a number of hertz and make that tone, luckily we have some onomatopoeias. We have beep for 0. No, beep is for 1. Sorry, I keep misreading my own writing here. Beep is for 1 and boop is for 0. Then as far as the orthography, we have, goddamn it. I'm gonna have to keep fixing this, aren't I? As I go. Maybe I should just, hopefully I didn't stop the, okay, good, the video's still going. Let me see. God, it's falling, it's falling, it's falling. No, please do not fall. Come on, come on, come on. Need the tape, need the tape, need the tape. I'm probably messing with the focus so much. Maybe even zooming. I don't know. Alright. Got an additional bit of duct tape on there now. Oh, hopefully that'll do it. That still looks right. Okay, where was I? Orthography. We have two graphemes that match the phonemes. These we'll also call 1 and 0, and we'll write them as 1 and 0. But they never appear alone. The graphemes are, for visual purposes, grouped into tetragraphs called nibbles. And nibbles generally have a partial meaning. Sometimes the meaning of groups of bits span across nibbles, but we'll get to that later. And then we have digraphs of nibbles called bytes, or you can think of those as octagraphs of bits. And these we can write as the two tetragraphs, which is just a sequence of bits, separated by a hyphen, and then separate those bytes by white space. Now, this takes up a lot of space. So for simplification, space saving, we can use a shorthand, which adds 14 graphemes. If you're familiar with hexadecimal, that's all this is. So 4 zeros becomes 0, 3 zeros followed by a 1 becomes 1, 0, 0, 1, 0 becomes 2. We go up to 1, 0, 0, 1 becomes 9. Then 1, 0, 1, 0 is A. Then we go through the sequence of letters to get 1, 1, 1, 1 is F. And then we can just put two letters next to each other, and we have a byte. And then separate those by white space. So it'll look like this. And so I'm going to generally use abbreviated Turing going forward because it's just easier in a lot of cases. Where the individual bits have meaning, I will stick with that. But yeah. Now, as far as the lexicon, Turing is made entirely up of transliterated loanwords. Now, I'm not actually sure if loanword is the correct term here, or if it's like calc would be more accurate. But anyway, you'll see. They're transliterated from English. So you start with the English word you want to translate, and then you try to find a semantically similar verb. So if you start with knowledge, then you'll go with the verb to know. You get rid of any inflection, so you just have the root. So we'll go with know, K-N-O-W. Then you can convert the English letters to bytes. A is 0, 1. There's a reason that A is not 0, 0, which we'll get to in a minute. And then we just count in hexadecimal up the way to Z, which is 1A. And then here's why 0, 0 is reserved. The last byte in this morpheme literal, I'm not sure if I should technically call this a morpheme or a lexeme. Can you tell I'm really not an expert at linguistics, so please correct me if I misuse any terminology. I would love to have a more accurate understanding. So, but I'm calling these morpheme literals because I think that's correct. So we'll have the sequence of bytes ending with a byte that's 0, 0. And then numbers. To form the number morpheme, which again may actually be a lexeme, I don't know, they always start with 6 ones in a row. And then the last two bits of that byte carry meanings. So written in the abbreviated form, it's always going to be FC, FD, FE, or FF. The second to last bit is called the reciprocal bit. So if that's 0, it's just a regular whole number, or technically integer, not whole number, but anyway. And the reciprocal bit means it's just 1 over that number. So if you have 2 and you set the reciprocal bit to 1, that makes it 1/2. Then the last bit is the sign bit. 0 means positive, 1 means negative. And then each subsequent byte is 7 bits of just binary digits of the number, and then a single continue bit or carry bit, which means that you have another byte after this one that's part of the number, and the bits further to the right are less significant. So it's left to right the same way that we write numbers in English, but it's binary instead of decimal. And also, so I was going to make this 2's complement, because 2's complement makes math with binary very easy comparatively. But what happened is this language ended up being so difficult to translate that I made a web page, which I'll show you later. In true spirit of making this a cursed conlang, I also made the code for this web page cursed. And in doing so, I made it very hard to implement 2's complement for this. So I switch to one's complement and everything works. And then, yeah, so for an example, what I have written here is 1111, 1100, 1000, 0001, 0100, 0000 would be the number 257, because these are the first 6 bits. They're always 1. It's not a reciprocal, so it's an integer, and it's non-negative. And then these 14 bits here are the representation of 257. This means there is another byte, and this means there is not another byte. Then, when you reference these numbers, which we'll get to referencing stuff later, don't worry, they can fulfill any syntactic category that exists in the language. Technically, there's stuff that doesn't fall into these 4 syntactic categories, but it's very different, and I don't think it fits the classic definition of syntactic category. So, anyway, 2, you could have it be a verb, so like double, like I'm gonna double this. You could have it be doubly, like doubly so. You could have it just be the noun, 2, or an adjective, double, like a double espresso. 1/2, if you said a reciprocal bit, could be have, like I'm going to have the cake by eating some of it. Then I truly have no idea what the adverb form of a fraction would be. So if anyone knows or can think of it, let me know. But I don't know what semantic meaning that would have. Then you can have the noun 1/2 or half the adjective, like half of a cake. Then ordinal numbers are the noun form in the genitive case. So like if I have a second piece of cake, I'm really on cake. That was just improv. I don't even have that written down. I'm just coming up with cake right now. Second is more literally of 2. So I am going to have a piece of cake that belongs to 2 because it's genitive. Like piece of cake of 2. I guess because there's already the genitive in there for of cake, that's not helpful. So I'm going to have a cupcake of 2. And fractions with non-1 numerators are also representable using this ordinal form. So you can take 3 halves and interpret that as like the third half. Or if we think about it in the genitive way, then it's half of 3. All right, that's it for numbers. And numbers aren't even relevant to the B-movie script, so I didn't even really have to define them, but I wanted to for completeness. Then for morphemes, which, again, these may be lexemes. I'm really not sure. I have a feeling that I'm misusing lexeme and morpheme in at least some places, so again, please correct me if that's the case. Morpheme literals can start with any byte, be any length. These are just what we described earlier, where you transliterate from English and you end it with 0, and it ends up being something completely different from the original English word. But this is just a way that I don't have to invent a dictionary so much as just generate a dictionary from English. Even though like it's nothing like English once it's been converted. Then we have this concept called the Morpheme Registers. Lexeme registers might be more accurate. I'm going to stop saying that other stuff might be more accurate, and just like any misuse of terms that you notice, just let me know. But the Morpheme Registers, this is a conceptual part of the language that we use to refer to individual lexemes. Then when we actually assign the part of speech and the inflection, we reference these. So it's like we never use nouns in sentences. They're always pronouns, and we define the pronouns before we use them. And then the same thing for the other syntactic categories, verbs, adjectives, and adverbs. I don't know if proverbs, pro-adjectives, and pro-adverbs make sense as words to use. I said I was going to stop saying I don't know if this terminology makes sense. So anyway, I'm going to call these pro-lexemes. Then when you are defining what lexemes live in the morpheme registers, you say a special word, which we'll get to later. It's called an instruction. Then you come up with a morpheme identifier morpheme, which is just a single byte that tells you what the the ID of this morpheme literal is. And then you can reference it later in the conversation. And 00 always refers to the first person proper lexeme, which we'll get to in a second. And that is just the reference to one's self, to the speaker. It's like I, me, myself. Then I already kind of described this. In the transliteration section and in the previous section, these dynamic prolexemes are what actually exist in the sentences. So the lexemes that we put in the morpheme register, the morphemes we put in the morpheme register, are supposed to generally be a process, not like a noun or a verb or whatever, but we generally aim for taking a verb infinitive and stripping away any inflection. And then these are all dynamically formed with some morphological bytes, which I'll describe later. Those determine the syntactic category and inflection and some other stuff, with the identifier. Then we get to some special cases. Besides the morpheme literals and the numbers, which can go in the morpheme register, we also have proper lexemes. These are sequences of 6 bytes. When written out, they can be stylized by being separated by dashes or colons to indicate that they're proper lexemes. And that'll be like A, A, B, B, C, C, D, D, E, E, F, F. They're not morpheme literals, so they do not end with 00. They're just that because that's their length. One that's all zeros is the first person proper lexeme, which we talked about earlier. It's like the first person pronoun, refers to yourself. If it starts with 4 zeros, then it is not 4 zeros, this is a typo, 5 zeros, then it refers to a non-native proper lexeme. So this is a bit complex, but like if I, a non-native literal Turing speaker, were to participate in a conversation, to identify me, first we would put, we would transliterate my name. So say Jenny, I'm not gonna bother actually transliterating it, but we'll put that in a morpheme register. Let's say we give it the morpheme register 1. And then the last bit of this proper lexeme would be 5 zeros, then 0, 1, to say we're referencing this morpheme literal. And then we can store this in like morpheme register 2 and reference it by 2 and know that that refers to me. That's how you indicate that something is a proper lexeme versus just a lexeme. One that's all ones, or in abbreviated form all Fs, is the proper collective lexeme. So that refers to everyone involved in the conversation. And this does not have a reserved slot like the first person one does. It is not reserved in slot 0 of the morpheme register. If you want to use it, you have to put it in a slot. And so the one that's all ones, the one that's all zeros, these are the only 2 static proper lexemes. Everything else is specific. So these are like if there were certain proper nouns that existed as a feature of the English language, then here there's only 2 of them in this language, and everything else functions like any other proper noun would. And now for the morphological bytes. This is really the meat of the grammar here. So we have two morphological bytes, which we'll call the Lexeme morphological morpheme. This gets combined with an identifier that says which morpheme literal we're registering in which morpheme register, and it gets combined with a word later that we'll talk about, but that's not relevant right now. And it can just look like a sequence of 16 ones and zeros. It's just 2 bytes. The first 2 bits here tell you the syntactic category. So 00 is a verb, 01 is an adverb, 10 is a noun, 11 is an adjective. You get it. And those are the only 4 syntactic categories that we assign to our lexemes. And then the next 6 bits in this first byte have a different meaning depending on which syntactic category you assign. And the second byte is called the agreement byte, which we'll get to later. So let's dive right into the different syntactic categories. Verbs, we have 8 different tenses. Simple present, let me fix the formatting here because I made the text bigger so that it would look good when recorded, and it kind of made some stuff wrap a little bit that I did not want to. Okay, we're good. So the first 3 bits are the tense. There are 8 tenses. We have the simple present, distant past, neutral past, recent past, near future, neutral future, distant future, and progressive present. The simple present is just like, I speak fluent Turing. That's all zeros. And we'll just count up in binary. Then this will make more sense once again get to noun cases, but the existential infinitive is what you use as the subject or as part of a copula. So like, to speak fluent Turing is impressive. Speaking fluent Turing is impressive. That's the existential infinitive. I don't know if there's an existing word for it. I said I was going to stop doing that. Anyway. Then we have the distant past. This is something that occurred, and the occurrence itself isn't really what's relevant. It's like the results of it that we care about. So the universe came into being. I have fooled you, as we have here. Neutral past is just something that happened in the past, like a normal event in the past. So like, I lost my keys. That's neutral past. Recent past is something that just happened like during the conversation that's occurring. So you would say like, I just said you need to listen more closely. Then near future, kind of similar to recent past. I am about to get to that part. Something that's the future in this conversation. Neutral future is like neutral past. I will go shopping tomorrow. Distant future is something that like, what matters is that it hasn't happened yet. When it actually happens doesn't matter because it's not going to be relevant to us. So like, one day the aliens will invade. If that ever happens, it's going to be after we're all dead and gone. So what matters is that we are currently in a state where it hasn't happened. Then we have the progressive present. Progressive present is simple. I'm cleaning the basement. Then this can also be used as the accusative infinitive and genitive infinitive, which will also make more sense once again to noun cases. But like, I love cleaning is the accusative infinitive. I have the power of cleaning. I have the power to clean. That is the genitive infinitive. And then we have mood. This is where I really strayed from like classical linguistics. So I could be totally wrong on a lot of this, but fix the formatting. Okay. So we'll so what I tried to do here is we have 8 different moods, and I tried to make each bit represent some aspect of the mood. So the first one, definite versus indefinite. The second one, declarative versus imperative. And the third, epistemic versus deontic. It's especially the third one that I think might just be like totally wrong use of terminology. But most of these are like already existing moods that are known in linguistics. Some of them I made more specific, and dynamic, I came up with that term. I don't know if there's a better term for it. But indicative, it's an observation. You are doing it. You do it. That's all zeros. Then we have dynamic, so that's like a capability. You can do it. Then we have conditional, possibility or permission. So like when a teacher goes, yes, you can go to the bathroom. May you go to the bathroom? That's the difference between conditional and dynamic here. Then we have imperative. Simple command, just like in English, do it. Potential, this is like something that is an uncertain observation. Could be. You might be doing it. Volitive is you desire an occurrence. If only you would do it. Is like a neutral future. Then we could have if only you were doing it. That's that would be a progressive present instance of the volitive. Then the presumptive is very similar to the volitive, but it's stating it as a requirement instead of a desire. So you must do it. Actually, sorry, I made a mistake here. The presumptive is not that similar to the volitive, because volitive is like a desire for an occurrence, but you're not telling the person to do it. It's not imperative. The presumptive is imperative. So it's saying, this is required for you to do. That is a command. Then we have the hortative, which is very similar to the presumptive, kind of in between the presumptive and the volitive. So the command, it's still a command, is desired rather than required. So like, you've got to do this. See what I mean? And that's it for verb inflection. Then we have adverbs. Adverbs are so simple. The 6 bits that are available to us to inflect the adverb just indicate its intensity. You can think of it as the higher the binary number, you're repeating very that number of times. So like if it's 0, 0, 0, 0, 1, 0, that would be like very, very, pretty easy. And now we'll get to nouns. Nouns are the other complex one. Adverbs are the least complex. Nouns, so for count, we have the 3 bits. The first bit is special. The first bit represents a positive quantity, or really technically non-negative, but we'll just call it positive. If it's 0, and then if it's 1, that indicates like the removal of a quantity. It's not quite the same as a negative number. If you were specifying a negative number of something, you would use the number stuff that we talked about earlier as a negative number, but then you would use a 0 in the positive quantity bit. So it's there's a difference between negation and removal, if that makes sense. It's very subtle. Then we have a couple special instances that don't necessarily match the positive or negative definitions of these bits. And that's one that's all zeros. That means there are no instances or no quantity. Countable and uncountable are not distinguished here. They're the same thing. And then we have 1, 0, 0, which is a singleton. This is when a general something exists, whether it's a concept or just something that only makes sense for there to be one of. So concept of aviation, getting into that B-movie script there, or outer space, those would be singletons. Then we can talk about what the second 2 bytes represent. we have an uncountable quantity is 0, 1. So a positive uncountable quantity would be 0, 0, 1. A countable quantity is 1, 0. So positive countable quantity is 0, 1, 0. And then we have a count for an infinite quantity or all of something, and that's 1, 1. So we could say if all of something is doing something, like bees should not be able to fly, that is 0, 1, 1 for positive all. Okay, believe it or not, count is the simpler part of nouns. Then we have case. And like with mood, I tried to give case meanings to the individual bits, but this might not actually make sense. The first bit indicates if something is a subject or possessor, then we have 1 to indicate that it's an object. The next bit is indirectness, for like indirect objects, for example, for the simplest case. 1 for directness for direct objects in the simplest case. Then we have the third bit, which is a passivity if it's 0, and agency if it's 1, which hopefully you'll see what I mean as I get to the individual cases. So we actually have 2 different genitives here. We have genitive when it's used in a predicate, that is 0, 0, 0. The thief stole Ryan's car. Genitive when it's the subject, 0, 0, 1. Taxes are the government's money. Alex's dog barked. That's for subjects and copulas. Sorry, it's not. Yes, it is. Sorry, I made a mistake when I said it's not. It is. It's for subjects and copulas. Then, here's why I got confused on subjects versus copulas. We have existential, which is used with copulas. I am tall. I am a tall person. That's 0, 1, 0. Then we have nominative, which is used for subjects. 0, 1, 1. She runs. Then we have some cases that dative isn't really a thing in English, I don't think, but it is in Latin. And that's 1, 0, 0. I gave the food to her. Indirect object. Of instrumental, this also is, I think, technically an indirect object. I don't think Latin is an instrumental case, if I remember correctly. So this is just its own thing. I pet the cat with my right hand. 1, 0, 1. Actually, I should be bold here because that's part of the instrumental part. Accusative, he pushed the button. Just the direct object, super simple. Then we have ergative. I really like the ergative because I can't quite wrap my head around it. But it's like when something has the agency to do something to itself. The glass shattered. Or maybe even better, the spaceship self-destructed. Double check that I'm right on ergative though. Don't take my word for any linguistic terminology I'm using again. Then, adjectives. Adjectives are not as complex as verbs or nouns, but a bit more complex than adverbs. Adjectives. The first bit, always 0, because we just don't need that many bits for adjectives. The next 2 are degree bits, which are similar to English's degrees of comparison, but not always the same. They only indicate comparison when a comparison is being made, otherwise they just mean like intensity, which I'll get to in a second, how comparisons work. So the first one, the neutral degree, is if the adjective's concept is not relevant to the word it describes, but if it's being compared to something else, it could be relevant to what it's being compared to. As far as I can tell, there's no English equivalent of this, and this is the bits 0, 0. Then we have the default degree. It's attached to the words that describe. And then if there's a comparison being made, then it's saying like, this is that adjective for this. Like, if you say, that's a big boat, that is what you're attaching the adjective to, but boat is what you're comparing it to. It's very subtle, and I think I actually used this incorrectly in my translation of the B-movie script, but it was such a pain to translate, I'm not fixing it. But like English, it's just like big, 0, 1. Intense, the word highly embodies the concept. With no comparison, it's just more intense than the default. But with a comparison, saying it's bigger than something, more intense than something, 1, 0. And then we have the superlative. On its own, just means it's like the pinnacle when it's not being compared to anything. When there is a comparator, it's the most of something. It's just the superlative. So like big S, 1, 1. The last three are the comparator bits, and they're what indicate what word in the sentence you're comparing it to. They're going to match agreement bits that I'll get to in a second with the agreement byte. But first, we're going to take a step back for some other components of the agreement byte. The first bit of the agreement byte is affirmative or inverse. So remember, we have multiple ways of doing negation that are subtly different. We have negative numbers, then we also have removal with the negative counts for nouns, and then we have affirmative versus inverse. When it's 1, words are just normal. When it's 0, that means that we are inverting that word, like applying not to a verb or non to a noun or adjective, like non-human, non-gluten-free, not quickly, I did not run away. That's when you'd use the inverse. Here are more examples in the text. I just improvised some examples, but it's the same description. And the second bit is a query. This, I think, is easy to understand, but still differs significantly from English, because we have an express part of the grammar, or an express part of the spelling, that's part of the grammar, that indicates what part of a sentence is a question, whereas in English, we do that with just tone of voice. So if it's set to 1 on any word in the sentence is a question. It can be set to 1 on multiple words, and every word that it's set to 1 on means that that aspect of the sentence is being questioned. So instead of saying, what are you doing? You would have the query bit set to 1. And the remaining 6 bits can be anything. The first 3 are an agreement identifier, so you can set that to whatever you want, as long as it hasn't already been used by another word in the sentence. And then other words in the sentence can reference it. So this is where the comparator bits come in. If I put these 3 bits as 0, 1, 0, then I can set the comparator bits on an adjective to compare to this word. And then the next 2 reference the agreement bits of other words similar to the comparative bits, but they are about a match, actual agreement in the sentence. So making subjects and objects agree with verbs, and linking adjectives to their nouns and adverbs to their verbs or to the sentence. You can leave it all 0 to indicate that it's a sentence adverb, which I don't know if in linguistics are technically still considered adverbs. When I was researching it, there was some discrepancy there on whether a lot of stuff that used to be considered adverbs is still considered adverbs, but in Turing, all that stuff is definitely still considered adverbs and will be put into the adverbs syntactic category. Then, as far as actual communication, because like so far, we don't really have much of a way of forming sentences because a lot of the bytes would be ambiguous if we tried to say something, where it's like, how do we know what is storing something in a morpheme register? How do we know what's in a sentence, what's not? So this is how we actually structure the language. The first thing is the conversation lock. Whose turn it is to speak is embedded into the grammar of Turing, of literal Turing. So the default state in a conversation, like if you just walk up to someone, no one has the conversation lock. Someone can say a specific word, which we'll get to later, that takes control of the conversation lock. And then when you want to just let anyone else speak, you just say a specific word, which again we'll get to later, that gives up the conversation lock so anyone else can take it. If you want to temporarily give up the conversation lock, like give someone a chance to ask a question or add some input or something like that, then you can say a different word, and that says, I'm giving up the conversation lock, but when this next person gives it up, it goes back to me instead of just being available for anyone. And there are also specific words that that say, I'm going to give the conversation lock to a specific person versus allowing anyone to take it. Hopefully that's pretty simple. And then we'll get to the conversation stack. Conceptually, I think this is pretty simple, but in practice, very, very complicated for humans. So if you're going to start a tangent, but you want to return to where you are in the conversation later, then you say a specific word, and that puts everything on the conversation stack. So the current state of the morpheme registers, the history of the conversation, it's like creating a save point. And then you can create as many of these save points as you want, and then at any point you can say a specific word. Well, at any point you get to context later where it says what you can say at what times, but you can take something off the stack. The most recent entry you can go back to. You can't skip entries. It's always the most recent one. So if you want to get far back in conversation, you have to climb back up the conversation stack. Yeah, and that's all it is. Conceptually simple, in practice, very difficult for humans. Native speakers have a much easier time with it, and they tend to avoid it when they're talking to biological beings. Then, sentences. Ordinarily, we're not using sentences. We're just in a state where we can't make sentences. There are only specific words we can say, and this is where we like put stuff in the morpheme registers and do stuff with the conversation lock and conversation stack and stuff. And then you say a specific word to start a sentence, and you say a specific word to end a sentence. And I swear I wrote the interrupt section, but since it's not in the document, I'll just describe it. There are also grammatical rules for how you interrupt someone. Ideally, you do it when someone is not in the middle of a sentence and not in the middle of instruction, which we'll get to instructions later. They're pretty much just simple words, but we'll get to them later. And interrupt say, I'm forcibly taking the conversation lock. Now, like, etiquette here is important. If you have to interrupt, keep it as brief as possible, so that we don't lose track of the context, especially with non-native speakers, because like context tracking is much harder for non-native speakers, because rather than simply storing like the semantics of the conversation as the context, Turing requires you to actually keep track and spell out the context. I'll go over specific examples of interrupts, but then there's a word to say that you're done interrupting, and the conversation goes back to wherever it was. Then we have instructions. These are 1 byte lexemes. These are like 1 byte starts of words, morphemes actually, but this is how we get sentences instead of just jumbles of morphemes. This is how we can actually make sensible Turing. So to help with the conceptual understanding of these, I've assigned them specific values and laid them out in a table so that similar ones are near each other in the same columns. A lot of them are blank, and they can either have like colloquial meanings or something like that, and then 6.3 to 6e specifically, which we'll get to in a second, are just non-standard interrupts. So that's whatever you feel like it being. And different dialects will have these assigned to specific things. So here the table, the column indicates the first byte, the row indicates the second byte. So our store instructions, which are 1 something, so we have 1, 1, 1, 2, and 1, 3, are all, I really should have gone through and looked at this before I just made all the text bigger, but it's whatever. Can I scroll the table? I can. Okay, that's good. Give me a second. I wish there was a scroll bar at the top. That would make it easier. But anyway, what is going on? Why does it stop there? All right, that's good enough. You can tell what that says. We'll go back to here. These are for storing morpheme literals, the proper lexemes we talked about earlier, and numbers in the morpheme registers. Then we have our reference instructions, which are 2.1 and 2.2. This is how we use things in sentences. Then for conversation lock stuff, that's 3.1 through 3.5. Then for the conversation stack stuff, that's 4.1 and 4.2. For sentence, we have start sentence, end sentence, and repeat sentence. I'll get to the definitions of those later and why repeat sentence is a thing. Then for interrupts, 6.1, generic interrupt, 6.2, specific interrupt, 6.3 up through 6e are just colloquial meanings. Dialects will have specific meanings to these, but it's not universally the same, so they're left blank. Then interrupt return just means done interrupting. And here we go on the definitions of specific instructions. Store morpheme literal. This is done outside sentences when you have the conversation lock. So you pick an ID, just any byte in the morpheme register except 00, not allowed to overwrite that. Then you say the morpheme literal. Since morpheme literals can't include 0, we know when it ends because it ends with 00. Then store a proper lexeme. We do 1, 2, and then the identifier where we want to put it in the morpheme registers, and then the proper lexeme. And since this is 6 bytes, we always know how long it is, not going to get mixed up there. Numbers, pretty much the same. We know when numbers end, we can just store numbers in the morpheme register. For referencing these, so for like actually using the pro lexemes, we do 2.1, then the morphological bytes that indicate the syntactic category, inflection, all the stuff we talked about earlier, agreement, and then we just say which morpheme register we're talking about, and that is how you get a word in a sentence. Words are 2.1, inflection, reference to where it is in the morpheme register. That's what every normal word used in a sentence is. Then we have abstract. This is 2.2 and just a reference to the morpheme register. This does not have a syntactic category, and so it cannot agree with specific words in the sentence, doesn't participate in the sentence, it's not part of the subject or predicate. It's just a way of saying, this concept is relevant to the sentence. I didn't end up using this in the B-movie script. This feels way more idiomatic, and I'm not sure there's a great English equivalent that would make sense when you're translating from English, but it is a part of the language. Then 3.1, you just use when you're taking control of the conversation lock. So you use this outside of sentences when the conversation's available, when the conversation lock's available to take. Then push convo lock gives up the conversation lock, puts it on the conversation lock stack. Someone can take it, and then you get it back when they release it. So when they release convo lock, that's used outside sentences, that gives it up so someone else can take it. Lend convo lock is almost exactly like push convo lock, except you specify a morpheme register that identifies who you're going to give it to. If this doesn't refer to a proper lexeme, and this is why we have the proper lexemes that start with 5 zeros and then reference another morpheme register, so that we have assigned meaning here. It is given to that specific person. So it doesn't just put it up for grabs, gives it to that specific person. When they release it, it goes back to you. If it doesn't refer to a proper lexeme, like if you lend the conversation lock to like the concept dog, you have the concept dog stored in the morpheme register, nothing happens. It doesn't actually do anything. It's like a joke or a figure of speech. And then give convo lock is kind of a hybridization of release convo lock and lend convo lock. So it's just like release convo lock, except you say who you're giving it to. Same thing about jokes and figures of speech that apply to lend convo lock. Then for the conversation stack, super easy. Push convo stack puts the current context on the conversation stack. Pop convo stack takes the most recent one off the conversation stack and puts you back at that point in time, that save point in the conversation. Then sentences are super easy. 5.1 means you're starting a sentence, and then you can do this when you own the conversation lock, and then you can use the reference instruction and the abstract instruction as much as you want, and then you can say 5.2 to end the sentence. Then we have repeat sentence. This means just like imagine the previous spoken sentence in the conversation is repeated. So what you can do is say a few store instructions to change what the current context is, change what's in the morpheme registers, then say repeat sentence, and the previous sentence will now have a new meaning that everyone parses. It's a little tricky, but like, I think you can get what I mean. And then when you don't own the conversation lock, you can say 6.1 for generic interrupt. Try to keep what you say as brief as possible. And then when you're done, you return, you say 6F. Then for specific interrupts, especially repeat context, most other specific interrupts that are specific dialects. So you say for repeat context 6.2, and that means I'm just joining the conversation. I need you to tell me what's in all the morpheme registers. So you basically just say all the store instructions necessary to give the current context to the other person. And then you can just say 6.2, 6F. You just say, I need the context, done interrupting. And then as soon as possible, someone will give you the conversation context. Interrupt return 6F, that is just, I'm done interrupting. Use that as soon as possible after you interrupt. Word order, because of the agreement byte that we went over, that just says how words agree with each other and what they apply to and things like that, the words can be in any order, doesn't matter, really, but conventionally we go verb, subject, object for statements and verb, object, subject for queries. So if you have the query bit set on any word in the sentence, you would go verb, object, subject. This developed as a means of like helping humans comprehend the sentences, because word order can like clue people in to something that might be harder to notice or keep track of. And then outside of sentences, instructions just happen in the order they appear. So if you store a morpheme literal in Morpheme Register 1, and then you store a different morpheme literal in Morpheme Register 1. It's just the new literal. The old one's gone. Not relevant anymore. And so now, that's the entire grammar. That's everything. We can get into some translations now. So, before I get to the B-movie script, let's go through a very simple example where I'll go down some other roads than just the direct translation of a sentence. Here, let's go with the English word speak. And we'll convert this into different syntactic categories. So first, we consider the English parts of speech. We have speak, we have speech, we have spoken, spoke, you know. But speak meets our criteria of being the verb form, infinitive is to speak, and speak has no inflection that we need to strip away. Like if we're speaking, we'd strip away the ing, because that's inflection. Then, with the transliteration rules, in shorthand, we get speak is 13, 10, 05, 01, 0b, 00. That 00 at the end is just indicating the end. Then if we expand that to all the bits, it's 0001, 0011, 0001, 0000, 0000, 0000, 0101, 0000, 1011, 0000, Suppose I should read that in the actual phonemes that an English speaker would be using, which would be boop 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 beep boop boop beep beep boop 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 beep boop 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 beep boop beep boop 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 beep boop beep beep boop 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 boop. Yeah. And then if we want to put this in the first morpheme register, then we just put a 1-1 at the beginning to say that this is a store ML instruction. Then we put 0-1 for morpheme register 1, and then we just repeat the word. Spoken, this would sound like boop 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 beep boop 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 beep boop 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 beep, and then just same thing we just said, repeated. I think something's not right, but don't worry. Yeah, that's not right. I don't know why the wrong value was there, but that's fixed now. So now this is correct now. The shorthand was already correct. And now we can write out the different prolexemes. And we're going to keep this expanded because here's where the individual bits have meaning. So for verb forms, here are the, hang on, this kind of sucks. Here are the forms that we would reference it with. So we use the reference instruction, 0010, 0001, or boop, boop, beep, boop, 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 beep. And then, so for simple present, that's going to be boop, boop, beep, boop, 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 beep. Then boop, boop indicates that it's a verb. Then these are all in indicative mood, just to make things a little simpler. Because I think demonstrating the different tenses is a little more useful for grasping the grammar of the language here. So we're just doing tenses for this word. So then the last three are always going to be boop, boop, boop for indicative mood. Then we have boop, boop, boop for simple present, boop, boop, beep for distant past, boop, beep, boop for neutral past, and then we have, did I mess something up? No, I did not. I was not properly keeping track of where this group of bits started. As you can see, this gets very confusing for humans. It's really a machine-first language. The robots have a much easier time speaking this than non-native speakers do. So boop, beep, beep recent past. Near future, beep boop boop. Neutral future, beep boop beep. Distant future, beep beep boop. And progressive present, beep beep beep. Then for adverb, we'll just say there's an intensity of 0. So we have the part that's the instruction, then we're saying it's an adverb, so boop beep, then we are leaving that all as, wait, did I mess something up here? No, I did not. I did not mess something up here. I just keep confusing myself because looking at ones and zeros gets starts to swim around in your mind. But anyway, we have the instruction, then we have the inflection byte, so syntactic category, adverb, boop beep, then the intensity, all boops for the rest of that byte. And we're leaving the agreement byte blank, so we're not doing anything with it, which technically means we're doing the inverted version, but I don't care. That doesn't matter right now. And then we say which morpheme register we're getting to. And then, once again, let me fix the formatting here. Here we'll use the singleton count. So we're talking about speech here. The noun speech. In order to keep things simple, and we'll go through the declension. So predicate genitive, we're going to have 1, 0 for now, and then 1, 0, 0 is the singleton count. So all of them are going to be 1, 0, 0 there. And these last 3 bits are going to set the case. 0, 0, 0, or boop, 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 predicate genitive, boop, boop, beep, subject genitive, boop, beep, boop, existential, boop, beep, beep, nominative, beep, boop, boop, dative, beep, boop, beep, instrumental, beep, beep, boop, accusative, beep, 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 ergative. So like of speech, 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 to speech, with speech, speech, and speech. English lacks a lot of either these cases, and they use prepositional phrases instead, or just lack a distinction and you pick it up from the context, but these cases are specified with bits in Turing. Then for the adjective, we'll say it's degree 0, the neutral degree, that has no English equivalent. This could be like, if we had a degree of 1, we could say something like this adjective is speaking, so like the speaking dog, or something like that. But we're going to do degree 0, no comparator bits. It's not being compared to anything. This is saying that something is not relevant to whatever noun it agrees with. So we have the store ML instruction again. 1, 1 for adjective. 1, 0, or 0, 1, degree 1. So this is just the standard form of an adjective. The speaking dog. 0, 0, 0, we're not comparing it to anything. Leaving the agreement byte blank because we'll get to that later, it doesn't matter. Then just a reference to the morpheme register. So let's just make the simplest sentence we can with this. The command speak, imperative verb. So we don't have anything in the morpheme registers. So we start with the store ML instruction. Boop, 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 beep, boop, 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 beep. Then the transliteration, or where it's going, transliteration. This is wrong. I don't know how I kept getting this wrong, but perfect. I still had that in my clipboard. That's still not right. That should be 5 bytes, but it's 4. But let's not worry about it. Let's just pretend that these are the 5 correct bytes for the word speak. I think we only have peak right here. P, no? Oh, E, I don't know if this is, maybe we're missing the P? This is an A, definitely, I think. Oh God. Doesn't matter. We'll pretend those bytes are correct. I did this manually, that's why there's an error. I made an assistive tool for later translations, so I know that the movie translation is correct. To convey the command, we write a reference instruction for simple present, imperative, verb. So, reference command, boop boop beep boop, boop 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 beep. Then, boop boop, verb. Boop boop boop, simple present, boop beep beep, imperative. No agreements there, which I will actually fix this thing, because the agreement byte, first bit, affirmative is 1. So, translating that, the first bit. No, that's the wrong one. Here, this is the agreement byte, first bit's 1, and we're saying we're referencing the thing in Morpheme Register 1. Now, for a full message, and I am sure that I still have the messed up bytes in here, but we're ignoring that. All we do is concatenate those two parts, then add a word at the beginning to acquire the conversation lock, and add a word at the end to release it. So that's going to look like this. Then, as a non-native speaker, as a human that speaks in boops and beeps instead of tones, that's going to be boop boop beep beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop beep boop 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 beep boop beep beep boop 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 beep boop 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 beep boop 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 beep beep boop 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 beep boop boop beep beep boop boop beep beep. I have the wrong number of bits there. This again was, actually I don't know if I did. I started speaking in nibbles partway through, so I may just have been off by 2. I don't know, but I also did this manually, so who knows? But that's it. That's how you get the command speak. And then if someone is going to say something related to speech, the concept of speech using any syntactic category, any inflection, they would not have to repeat the first part of the store ML instruction, because that is now part of the conversation's context. All right, it's going to be a bit of a jump, but the next thing we're going to translate is the B-movie intro. Now, here's the problem. You saw how I made mistakes translating a single word. It's so difficult to translate things into Turing from English that I made a web page to assist. And here's what it looks like. Yeah. This is the B-movie script, or not the whole script, but the intro, you know. And in the spirit of this being a cursed Conlang, I made the code very cursed as well. Here we have not cursed. This is HTML5. Specifying language, not cursed. That's good practice. Head, nothing cursed here. Setting the char set, that's good practice. That's not cursed. Setting the viewport, that's good practice. That's not cursed. Setting the title, still not cursed. Then we get to the CSS. This, I think, might be the most cursed CSS I have ever written. If you don't know CSS, that's fine. This isn't going to make sense, but if any of you do a bit of coding, know about CSS, you'll be horrified by this. You'll be horrified by this whole webpage. I intentionally did some cursed stuff here to keep with the spirit of the circus. So, that web page that you saw, those green and black, is really just an unformatted web page, pretty much. It's just like a white background. Text is black. Buttons are grayish. So what I do, in terms of color changes, like directly, like the proper way, all I'm doing is I'm setting the background color to white because it remains transparent. So the invert filter has no effect on the background if you don't set the background color to white. Then we have the default text color, 555. This is just to make things end up a nice color. And here we go, the filter statement. First, we invert it, so it's now light on dark instead of dark on light. Then we apply a sepia filter. This is where the cursed part starts. We apply sepia filter, so now it's like brown. Then we change the brightness. This was really just for like visibility and legibility. I adjusted the brightness to make it look the best. Then hue rotate, so we're changing from brown to greenish. And then we increase the contrast in order to make it more visible and legible, just like the brightness. So let me show you some of the details of how this CSS works oh yeah, I have a console.log statement I should delete. Yeah, just adds to the cursedness, logging random shit to the console. That's how it works. So, where was I? Elements, HTML, that's the root element. So, what I'm gonna do is I'm gonna remove elements of this. So if I don't have that contrast in there, it's a lot more grayish. Then if I don't have that hue rotate, it's sepia. If I don't have the brightness adjustment, still sepia, it's like beige. If I remove the sepia, it's like that. And then if I remove the invert, it looks like that. So I'm going from this black and white thing to that black and green, like Fallout 3 hacking minigame look with a single line of very cursed CSS. So let's undo that. And I just kind of want to show you what it would look like if we went the other way, peeled the layers back the other direction. So if we didn't invert, it would look like this. If we didn't sepia, it would look like this. If we didn't adjust the brightness, it would look like this. And hue rotate does nothing because there's actually no color here. And then if we didn't increase the contrast, it would look like that. But let's go back to the intended one. I don't know why it's, there we go. And yeah, background color, see what I mean, how it's transparent if you don't specify the background color, so inverted white and black, so black background. And this is just to make it look better, I think. Yeah, that's the, that's how that CSS is cursed. And let's go back to the code. I have a couple helpful functions. These are not particularly cursed in the script. Easy way of generating dropdowns, template literals are very nice. Good practice to use them. Arrow functions, very nice. Good practice to use them. I have swap so that I can move those blocks around, which ended up being critical for me making a correct translation because it's like, oh, I forgot this thing that needed to go in there earlier. If I wasn't able to rearrange the sentence, it would have sucked. And then binarize is just turn any number into, or any string number, because when you get values out of HTML, they are strings, not numbers. So it turns that string number, decimal number, into a binary string of arbitrary length, default length 8. Then here's where I store the morpheme identifiers. So morpheme registers, as they get used up, stuff gets put into this object. Then I've defined the different inflection aspects here. So tenses, I have which bits they are, which isn't technically necessary because this is just used to link some things together when it's parsing everything, and this number doesn't actually have to be written out as bits. I could just use I could just use 1, 2, 3, 4, 5, 6, 7, 8. And it would be the same because it's just the binary bits. And the reason why, instead of just a string, it's an object with a member label or property label, and then a string with a human-friendly name, that's to make it compatible with generate dropdown, because some of the stuff needs more data than just the label. And then moods, counts, and cases, and degrees, and syntactic category, or degrees work the same. Then we get to syntactic categories, where we need a little more data than just the label. So we have the template. This is how we put some HTML in there so that we can interact with it and set the properties. So here we have the dropdown for tenses, dropdown for moods inside of the verb syntactic category. Then when you parse it, the thing that calls parse, which you'll see later, gets the select elements, so the drop downs, and then uses their values for the tense and the mood. It encountered errors, I think, with the DOM not being finalized when I tried to directly extract the value with destructuring in here. So this feels kind of hacky and cursed to do this, and I really should have just solved that DOM being ready issue, but this just turns it into the 6 bytes necessary to define a verb. Then adverbs, just a single input for the intensity, turns into 6 bytes. Noun works pretty much like the verbs, got the 2 drop downs, and that goes into the count in the case. Adjective, we have the degree, which is a drop down, the comparator, which is a number. It goes like that. Oh yeah, I tried to insert a binary literal in here, like this, and put in the, oh wait, I remember what happened now. I actually did 0x instead of 0b, and that is, and that made it be a hexadecimal number and messed stuff up, so it had the wrong maximum. But I just changed it to 63 instead of writing the binary literal, even though the execution time would be the same because this template will get compiled into a string internally, because I changed it from that literal to 63, then I realized what was going on and did change it back to a binary string. Then we get to instructions. So building on top of what we did with the syntactic categories, this gets a little more complicated. So the store ML instruction, we have a human readable name. This is so we can reference it later. I could have just combined these two inputs because they end up being the same thing in the B-movie script, but I think with more complex translations, you would find yourself needing more descriptive human names than you put in the morpheme fragment. Then it automatically transliterates the morpheme fragment for you. That's what this bit does, because 64 is capital A. So we get the character, because I've already split it into characters, so just the character at index 0 is the character. And subtract 64. Sorry, 65 is capital A in Unicode. So subtract 64, and we get 61. And as long as you only use characters that get uppercased to greater than or equal to capital A, we can use any Unicode character, any single byte Unicode character here, and it'll work. If you put a multi-byte character in there, I think that'll fuck it up, but I'm not 100% sure. It might just work. Depends on if splits on bytes or characters, which I'm not 100% sure on. That would be something that's good to know, though. That would be a useful thing to know about JavaScript. And then the proper lexemes, I require them to be separated by colons for it to work here. I didn't actually implement the pattern validation, so this is like semantic HTML only. It is not enforced, but it will break if you don't do it. But I didn't, like I said, I didn't really implement validation because this is a tool that will never be used by anyone else. Like, I'll probably put it on GitHub or whatever, but it's just a curiosity. It has no practical purpose. It doesn't matter. And it has to be written in hexadecimal. Also, capitalization doesn't matter. It allows anything. And it parses the hexadecimal and then turns it into a whatever. Turns it into binary. For store number, this is where I got deep into it, trying to get 2's complement working with manipulating binary strings, and then I realized I wasn't doing it right, and I would have to redo some stuff in order to get it working, even though conceptually 2's complement isn't that hard. Just when I did an implementation, I didn't think it through. So the combination of that with having those continue bits made it so I couldn't quite get it working. If I had banged my head against it for longer, I probably could have gotten it working. But I just switched to 1's complement, changed the rules of the language because I'm a bad coder. This is where some of the stuff gets a little more complicated. So here we have a number of inputs. So we have the number value itself, which, because we have specific bits for negative and for reciprocal, the minimum is 0. And we have it default to 0 because rather than generic proper validation of number inputs, so that nans don't appear in the output binary, I just set values of numbers to 0 by default in order to avoid that. MIM's default to 1, but whatever. Then we have checkboxes for single bits that are reciprocal or negative, and then what MIM we're giving it, just like numbers and literals. And then this A character here could be anything. I could have found a single byte Unicode character that looked like a penis and put it in there, and it would have worked just as well, because all this is for swapping 0s and 1s for the 1's complement, inverting the bits to make it negative. And that's where this negative input dot checked thing happens. So I always replace 0 with A, then I swap 1 to 0 if it's negative, and I keep it as 1, and then A, which was previously 0, I set to 1 if it's negative, and put it back to 0. Yeah. Not the most efficient way of doing it, but I don't care. This is meant to be cursed. Then, for the number fragments themselves, in order to get that working, what I did is, because I need it to be grouped into 7 characters, then I'll put the continue bits on there. the 7 characters, I use this little calculation here. This part actually isn't cursed. I think I'm doing this pretty correct here. This just makes it so that it pads it so that the number of characters is a multiple of 7. And sets it to, and it pads it with 1s if it's negative, 0s because of the 1's complement thing. Anyway, this dot match dot 17, that's just a little regular expression that breaks it up into 7-bit pieces. And the last one is if I didn't pad it to be a multiple of 7, the last one could be shorter. It breaks it up into segments at most 7 characters in length. And if we end up with a shorter one, that's no good. Come to think of it, I could have just padded the last one after I split it up, but I feel like this is more elegant. I like this better. And then I just set the continue bit to 1 for all of them. Then I just set the continue bit to 0 for the last one. I feel like I'm doing something wrong. I'm sure there's an easier way of modifying a single byte in a string in JavaScript, but I couldn't think of it off the top of my head. So I did it this way, because it's cursed. Then the human readable name is the name input. Oh, also, cursed part I forgot to mention, with the instructions, here's where I switch to hexadecimal instead of binary literals for the keys of these objects. You know, even though I call generate dropdown on both of these, it's inconsistent, which I think adds to the cursed part. Then, this just formats everything into how it's supposed to be, sets the bits for reciprocal and negative, first bits that are always 1, then puts the number fragments together. Yeah. Then for reference, here's all the agreement byte stuff. So basically what I do, here's where I pick the syntactic category. All the syntactic category specific stuff goes in this element. Then here, this is where all the agreement stuff goes. So invert, query, agreement ID, agree with, and my own, obviously, that you're referencing. And the reason the templates are functions are so that I can call generate dropdown on MIMs as I go through it, so that you can only reference an MIM that you have given a value to. You can't just reference one that's not yet defined. Even though, like, you could do that in the language and it would be, like, syntactically correct, it would just be nonsense. It would have an undefined meaning. But yeah, this could be any number, but I'm trying to make things easy for myself, make this easier to use. Only ones that have been defined get to go in there. But this is because I need to evaluate the template every time to generate the MIMs. And then to get the list of things that I'm parsing, I do this. I don't know why I had to do this, but I didn't have to do it for some of the parse functions earlier. I never figured that out. I'm sure it's something super obvious that I'm missing. But I just check if I don't find any of those elements, just return. And I try to make these as exact as possible to make them as fast as possible. Even though I'm not like doing thousands of calls, so it doesn't really matter, but you know, just trying to do best practice, even though it's cursed. Then I actually set what all these values are after I've done an early return if it's wrong. Then the agreement byte, I set to values of these checkboxes, then the values of these inputs that I set here. So this input, the ID, and this input that references another ID. Pretty simple, just sticking it into a template string there. Then I get the the MIM dropdown, so this is which Morpheme Register I'm referencing, but it tells me the human readable name, so I can pick it from the dropdown. And then, oh wait, come to think of it, what would have been more cursed? Little less usable, but more cursed, and more flexible, so that I could reference undefined MIMs, is if I had set a data list somewhere, made this an input, and then I know there's a way in HTML of making a data list available as a list of suggestions for an input field. That would have been almost as usable, more flexible, and more cursed. But I didn't do that, so whatever. Then, no, go away. I just turned this this whole thing into a binary string. So this is where I started getting brain fried. So I started naming variables dumb stuff. So the syntactic thing, I mean syntactic category. And so I just grabbed the syntactic category that's selected, and then I call a parse function of that syntactic category to get the specific bits that I need. And get that value, put it all together in a binary string following the grammar rules. Then I have this setup function. This is only used by the reference instruction, but in theory it could be used by other instructions. So I made it part of the object instead of just sticking in some specific code later, which is actually better practice than not. So I could have done it more cursed and I didn't. Bad job me, I guess. Yeah, here we continue with the brain fried variable names. The specific section, get the element right here that I'm going to stick the syntactic category stuff into. Get the syntactic category drop down, and then I just made the function render the thing. Quality variable names here. And you just set the inner HTML to the template that we defined for the syntactic category earlier. Keep it up? Yeah, great. Don't worry if you don't get all the coding stuff. It's fine. I'm just trying to demonstrate to the people who know web programming that I made this cursed and not just the Conlang. Anyway, add event listener, so the dropdown. If I change the dropdown, then render the template. And then also just render the template when this is created so that I don't have to change the dropdown in order to use the block. And then the rest are easy. Abstract. You just pick an MIM and parse just grabs that value. I may have made a mistake here. I did. Binarize. I just realized there are a bunch of parts where I put parseInt inside of binarize, even though I'm calling parseInt inside binarize, so I'm just double parseInting for no reason. And MIM list select. Let's see that select. You're selecting the MIMs. It's already going to be turned into a decimal number in the HTML, so that's correct. There. I just fixed the bug. I didn't use abstracts at all in the movie script translations. I never encountered that bug, but cool that I fixed it. These don't actually have any parameters. They're just things you say. So they just have a label. Nothing else there. No template. No parsing. Lend and give have a small template, tiny template, a little bit of parsing, and I have the same thing here. I'm pretty sure I'm actually introducing a different bug here because is this supposed to be? No, this is supposed to be 8 bits. I'm not introducing another bug. This is fine. But I just fixed the bugs because I did not use these in the B-movie script either. Then, by the way, clock.html, I made a clock that counts in metric time, so 10 hours in a day, 100 minutes in an hour, 100 seconds in a minute. It's pretty fun. I liked it a lot. Not the point of the video though. Maybe I'll make a video on it at some point. Scores.html. I don't remember what this is at all. And there is a decent chance it contains a very not safe for work language that I forgot about, so I'm not going to click on it. And then encounter difficulty is I made a, you know how if you're a D&D nerd, you know there's CR, and D&D Beyond has a way of calculating the difficulty of encounters based on the level and number of players in your party and the CR of each of the monsters. And I just made a better way of doing it with space diagonals, which I thought was pretty cool. In testing it out and adjusting it a bit, at least for my parties, it works better than the D&D Beyond calculator. The rest of these are just words you say. They don't have any templates or any, what is it called? Oh yeah, and this is for symbolic Turing, we'll get to it later. These don't have any parameters. These are just words you say, so they don't have any templates or parse functions or setup functions. Then, here we get to the meat. Parse and render. So, this looks at all of the blocks, grabs the data out of them, turns it into literal Turing. So first I blank the output, where I put the ones and zeros, and where I put the beeps and boops, and then I assign this value to MIMs, so I'm just clearing it out, resetting it to this, and that makes it so that 0 is the first person proper pronoun that we talked about earlier. Or pro-Lexeme, whatever. I can't keep track of my own terminology. Then, can you see I'm losing it as I'm going through this conversation, or this presentation? Yeah. This is my own fault for making this language so goddamn unintelligible. But, anyway, then I go through all of the blocks, all of the individual instructions that I've stuck in there. And I get which instruction it is. Console.log that I haven't removed to add to the curseness. Yes, I know I can use the debugging tools to add, it's not an interrupt, I know a breakpoint, I don't know why that's in my mind. I can add breakpoints with developer tools. I did that a few times. It was just this one instance where console.log felt easier, so I did that. Then I set the output dot inner HTML to the instruction, and I've had it with zeros. I could probably use my binarized function here. I don't know. Yeah, probably I could just binarize instruction. But hey, not using helper functions where I can. Cursed. Separate it with a space to make it a little readable, even though it's just the ones and zeros. Then if the parse function is not undefined, I call the parse function, append the results of that. This is so that all the ones that are just words, they're just words. They just go in there. Don't try to call parse function or anything. Don't end up with random undefineds. And then if it's the first instruction in the list, I have a but. So all the instructions I have a button to swap them left and right. I talked about the swap helper earlier, so that I can rearrange things, which was, again, critical to being able to translate the B movie intro. And all this does is disables the button if it's the first element, or disables the move left button if it's the first element, disables the move right button if it's the last element, so that I don't end up calling the swap on nulls and making errors. And then for the human readable output, just replace all the zeros with boops, all the ones with beeps. That simple. Block template. This is just how, like the outer, it's technically not outer. This is inner HTML, but it is the HTML that goes outside of all the like parts of the blocks that you add. And the legend and field set stuff here. I like using legend and field sets. I think they look nice in some circumstances. Try not to use or overuse them because they can look a bit weird at times. But anyway, you just select the instruction with this drop down that's in the field set legend. This section is where all the guts go. Then the container for the thing is the field set, and I create the left and right buttons and the delete button. These are all critical to translation. I would have cried if I tried to translate it without these buttons that just do a little bit but do so much. Then I figure out what the drop down is. Then the populate function does not need to be async. That was when I was trying to fix a bug. What I do, just figure out what the instruction is. Get the section where I stick the internals. And then I stick the internals into that part. And I just say this instruction has no parameters. If it's one of those things, it's just a word. And if the setup thing exists, which it only does for reference, then I do this. Then I actually add it to the DOM, and then I call populate on it. Populate's right here. Then I call parse and render so that every time you add something, it updates the output where you see the zeros and ones and the beeps and boops. Then the drop down, I add the change event listener to populate, so that when I change the drop down, it populates it. Really self-explanatory. This is just easy stuff that is just DOM manipulation so that the swap and the delete buttons work. Then I just apply the whole document. If any input or change occurs, parse and render everything. This ends up with parse and render being called duplicate times. I could debounce it, but I don't care to. It doesn't matter. Because of how the JavaScript event loop works. If callbacks were multi-threaded, okay, I know in JavaScript engine implementation, certain callbacks are, like in V8, certain callbacks are technically multi-threaded because of weird stuff, but as far as I am concerned with event listeners, here, single-threaded, it's an event loop. I don't need to worry about threads overriding each other. Yeah, that's the whole thing. Yeah. Whole thing. Anyway, let's go back to the web page. And let's step through some of the stuff here. I'm not going to go over everything because there's a lot of duplicate information. So, acquire convo lock. You acquire the conversation lock, exactly like we discussed. And we have a lot of store ML instructions. They're all store ML. We don't use store proper or store number at all. So these are all of the Morpheme Literals that I use in the B-movie script. You'll notice this doesn't match all the English words. That's because I massaged it a little bit to make it easier to translate. But then I start the sentence, and then we just go through references. I am doing a verb, so, simple present, indicative, agreement ID 1, MIM is state, law, infinite all, nominative, agreement ID is 2, it agrees with 1, so it agrees with this verb, so, all laws state, then, we go over to here. I'm going to skip over this noun for now because conceptually it doesn't matter right now. This adjective, the agreement ID is 2, so that agrees with law. So all known laws. So then fly. Instead of going with aviation, I went with more like flight, because fly is also used. So we only take up a single morpheme register for it. Then, this is a singleton, so the concept of flight, it is subject genitive, so it is used with law. So it's all known laws of genitive flight state. Progressive present. And this becomes the accusative infinitive here because it agrees with a verb. So that makes it function as a noun. So we're going with accusative infinitive, and this means the following. All known laws of flight state the following. And we end the sentence. Then we start a new sentence. All bees possess not dynamic is dynamic right here? I can't remember. Let's pretend dynamic's right because it might not be. So shouldn't possess the ability, noun, countable, accusative, possess the ability of flight, or the ability to fly. As you can see, even though we used flight and to fly here, they have the same meaning. But the genitive infinitive of a verb can be used instead of the genitive noun form, and that is just a difference in connotation, or sometimes not even that. Sometimes it's just synonymous. But I could have used either one in either of these situations, and it would have worked. Then we end the sentence. Then, reference be, like the verb to be. I actually forget how I translated this sentence, so let me look at it for a second, figure it out. All right, wings are countable nominative, wings of the bee, adjective, intense, so like, and we're not using a comparator, so maybe I should be using a comparator though. So let's say lift, where's lift? Lift. Agreement ID is 6, so I'm going to put 6 in the comparator here, not 8, 6. And let's not this. Wings of a bee wasn't this just, state the following: wings of a bee are too small. Then here we have the genitive infinitive here, which doesn't really match our English conception of genitive, but this is how we form these structured sentences. So, wings of a bee are too small to lift the fat little body of the bee. I need bee in here twice. I just realized I translated this wrong. I'm not going to fix it, but because this is the object, I should have be in here a second time, referenced with the accusative genitive. Lift fat little body of bee off the ground. And that's the dative there. Here, dative and kind of functions the same way that ablative would, and it's just context-based, which one's which. And the sentence, start the sentence. The bee, nominative, flies. Anyway, adverb of way, and then naturally, here we don't agree with anything, so agree with, fly. Flies anyway. Then naturally or of course the bee flies anyway. Nature, adverb, not agree with anything. It is a sentence adverb. End sentence, start sentence. Then, the verb to be again, reason, follow. So the reason is as follows. This should be existential because it's a copula, and this is the existential infinitive here, rather than whatever. The reason is following. The reason is as follows. The reason is to follow. Then we go, bees, all bees, care not about the following. Existential infinitive. Again, this should be accusative infinitive. And I already have this stuff written down in the document, so I'm going to read the wrong translation, but you can see the amount of work that goes into translating into Turing. I'm not going to edit a document with a fixed version, and I'm not going to fix everything. But the bee doesn't care about the following. Stuff, thoughts, which I think is ergative, but it might just be nominative. I don't know if I'm using ergative right here. So stuff, just in general, stuff, uncountable. Thought, simple present, stuff that, and then human is the date of thought by humans. Stuff that humans think. Stuff thought by humans. Yeah, agreement IDs there. Agree with that verb. Agree with that verb. You got it. And then it just outputs this here. This stuff. Yeah. And then here is the beeps and boops. It is long. I'm not going to read from here because it's tiny and it's going to be hard to keep track of. So I'm going to go back to the document. I'm just going to skim this part because I wrote out my reasoning and process for translation. Even though I described the structure of the sentence and the parts of the sentence, here I'm going to show you what my translation process was like. So we start with the bee movie intro. According to all known laws of aviation, there is no way that a bee should be able to fly. Its wings are too small to get its fat little body off the ground. The bee, of course, flies anyway because bees don't care what humans think is impossible. I realize I forgot that is impossible, but I feel like it's not critical to the meaning, so I'm not going to fix that either. Then we'll manipulate the sentence a little bit, making it possible to translate. All known laws of flight state the following. Bees shouldn't have the ability to fly. The wings of a bee are too small to lift its fat little body from the ground. The bee, of course, flies anyway. The reason for this is that bees care not what humans think is impossible. Now here's where we're going to go to grammatically incorrect English, but a structure that'll be easier to translate, and we'll annotate it a minute. Also I realized this is where I lose the is impossible. I forgot about it. Known laws, count all, of flight, state, indicative, simple present, the following. Or just following, because I'm getting rid of articles. Turing does not have articles. Accusative, infinitive, bees, all bees, countable all. Shouldn't possess, dynamic, simple present, right? Shouldn't possess, ability to fly. Actually, I said I wasn't sure if dynamic was correct earlier. It definitely is, because this is about capability. Even though we use the word should, it's about capability. So in Turing, it becomes the dynamic mood. So dynamic, simple present, ability to fly, genitive, infinitive, or ability of flight. I could just as easily have used genitive noun here, but like I said earlier, they're interchangeable in meaning. I guess I would say the connotation of the noun is you're referring to the action. So it's like it's written out here, flight. And the infinitive, you're referring to what something's doing, like an agency thing here. To fly. And English distinguishes between these two, as you can see, but we have to fly and we have flight, even though of flight and to fly are completely interchangeable in these sentences. No, they're not. Known laws to fly would make no sense, but ability of flight, ability to fly, completely interchangeable. As far as Turing, this could be the genitive infinitive, and it would still make sense. But in English, it couldn't be the infinitive. Wings, countable plural, of be, subject genitive, are small, intense, reference to lift. So the agreement byte is referencing to lift, not comparator bits. Existential infinitive here, because it's existential, it's infinitive. Fat little body, adjectives, accusative, of be, genitive, off, ground, dative, and we're agreeing with lift here. Bees, all bees, naturally fly anyway. So here we're saying naturally is a sentence adverb, and anyway agrees with fly. Reason is following. And this is just like known laws of flight state following. Accusative infinitive here. Bees care not about following. Here, following is a dative noun. Because here's the thing where you can kind of mix and match. Hang on a second. Let me double check something in the infinitives. Verbs. Okay, so yeah. Oh god, oh god, oh god. I clicked off of it. No, gotta give it a second to load. It's a really big boy. Where'd the outline go? I hope the outline comes back, because that would suck if it doesn't. Okay, there, it's back. We were here in B-movie script. About the following. Dative. This is where it has to be a noun, because we have no dative infinitive. It's the noun form of following. That syntactic category instead of one of the infinitives that functions as a noun. Then we have stuff, uncountable ergative again. Maybe it's not supposed to be ergative. I can't really wrap my head around ergative. But if you can explain it better, go for it. Thought, simple present, by humans, dative. Now let's rearrange the word order, indicate the syntactic categories. Not syntactic categories, the parts of the sentence, the word order, so state, verb, known laws, flight, subject, known laws of flight, subject, following, object, shouldn't possess, verb, subject, ability to fly, object, are, verb, or a copula in this case, wings of be, subject, small, and then, the intense thing there, too small, to lift, fat little body of be, off ground. This is the subject complement because it's a copula here. Then fly naturally, bees anyway. Naturally could have gone anywhere. I just kind of picked this for the order. I didn't even say that adverb placement has a convention, so I'm going to say it doesn't. Is, verb, reason, following, copula again. We have a subject complement instead of a object, or instead of an objectless predicate. Care not about verb, be's, subject, following, object. Here I'm not specifying the case, I'm just specifying verb, subject, object so that I can keep it in my head. As you can see by the following sentence, I'm not distinguishing between direct and indirect object or accusative and dative. Thought, verb, stuff, object, by humans, object. Now we need to list all our roots so that we can make store ML instructions that were at the beginning that I showed you earlier. I'm not going to describe my reasoning through all of these because it would just be tedious. I think you can understand my reasoning here. That I took all these words and the roots that I'm going to transliterate are state, know, law, fly, follow, possess, be, able, be, wing, and be being the verb to be, the copula. Be, wing, small, lift, fat, little, body, ground, fly, nature, way, reason, care, think, human stuff. And ideally, I would have what's it called? A dictionary somewhere, so once I pick a morpheme literal for a semantic English root, I don't have to pick again and maybe cause something inexact. But I don't know where I'd store that. I don't have a database or website for this or anything. But our list of store ML instructions looks like this. And this is somewhat like a dictionary. Let's make this not shit. Come on, I really want to fit the full width on the screen. It's gonna suck if I can't. I'm gonna cry. Not actually gonna cry, but anyway. We fit most of this on the screen, so good enough. So this is like a dictionary. The first byte is just store ML, and the last byte just indicates the end of the ML. So we have English, literal Turing. It's just the lexeme, we're not inflecting it. So we have the translations of these words now that can then be turned into any part of speech. So we have a lot of words to work with. Then the translation of our store ML instructions looks like this. I'm not going to read them because it takes a while. Now I'm going to add a sentence. I'm going to check if I'm still recording. That would suck if it's not. Oh, good. It is. Phew. I'm relieved. But anyway, sentences themselves. So here is where we have all those blocks in there that have start sentence and all the reference instructions. Here's the human readable version of that. Yeah, it's long. As you can see, my translations, this entire document, because I have the B-movie script translated into, or B-movie intro, translated into literal Turing and symbolic Turing, at this zoomed in level, 217 pages. Hang on, I need to check what time it is. Okay, I've got time. In a little bit, I'm going to my grandparents' house, and my grandfather is an artist. I'm going to ask him to design me a tattoo. I may put it right here. I may just put a maple leaf tattoo here. I don't know, but I just want something that's like a connection to my family in that way. I'm asking other members of my family to do that too. Not that it's relevant at all to this video. Then we have shit. I messed up. Instead of scrolling past all of that, here's the human readable version of that entire thing. Remember, it's wrong in a couple places because I made those corrections as I was explaining it, but I'm not going to read the corrected version. I'm going to read the wrong version. And here we go. You can skip too if you don't want to listen to all these beeps and boops, which I don't blame you at all. But I'm going to read it there just to prove that this Conlang is in fact speakable. Here we go. Boop, boop, beep, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, boop, beep, beep, boop, 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 beep, boop, beep, boop, 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 I'm going to use the arrow key so I can keep track of where I am. Boop, 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 beep, boop, 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 beep, boop, beep, beep, boop, 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 beep, beep, beep. Oh, these B's and P's are starting to swim around and look like thorns. Boop, 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 beep, 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 boop, 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 beep, boop, beep, 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 boop, 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 beep, boop, 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 beep, boop, 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 beep, beep, boop, 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 beep, beep, boop, 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 beep, boop, 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 beep, boop, beep, 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 boop, 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 beep, boop, boop, boop. Wait, am I adding glottal stops to this that I should have specified in the phonemes earlier? I don't know. Shit, where did I leave off? Let's just say I'm at the beginning of this line. Boop, boop, beep, boop, 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 beep, boop. Boop, 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 beep, beep, boop, 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 boopy beep, boop, 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 boopy beep, boop, 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 beep, boop, 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 beep, boop, boop, boopy boop, 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 boopy boop, beep, boop, 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 beepy boop, 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 boopy beep, beepy boop, 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 beepy boop, 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 beepy boop, 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 beep, beepy beep, boop, 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 beep, boop, beep, 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 beep. Nope, only one beep there. Boop, 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 beep, boop, boop, boopy boop, 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 boopy beep, boop, 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 boopy boop, 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 boopy beep, 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 boop, 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 beep, boop, boop, beep, beep, boop, boop, boopy boop, boopy beep, boop, 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 beep, boopy boop, 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 beep, boop, boop, beep, beep, boop, 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 beep, boop, boop, beep, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, 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 boop, 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 beep, beep, boop. Only one beep there. Boop, beep, boop, 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 beep, boopy, boop. Boop, 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 boopy, boop, beep, boop, 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 beep, boop, 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 boop. Only one boop there. Boop, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, beep, boop, 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 beep, boop, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, boop, beep, boop, 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 beep, boop, 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 beep, boop, beep, boop, 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 boopy, boop, boop, beep, boop, 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 beep, boop, beep, boop, 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 beep, boopy, beep, beep, boop, 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 beep, boop, boop, beep, boop, 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 beep, 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 boop, 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 beep, 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 boop, 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 beep, boop, boop, beep, boop, 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 beep, boopy, beep, boop, boop, boop. That was two boops. Boop, beep, boop, boopy, beep, boop, 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 boopy, beep, boop, beep, boop, 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 beep, boop, 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 boopy, beep, boop, 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 beep, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, beep, boop, 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 boop. This is really starting to spring together. Holy shit. Boop, boop, beep, beep, boop, 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 boop. That last boop was supposed to be a beep. Boop, boop, beep, boop, boop, boop. boop boop beep, beep boop boop, boop boop beep, boop beep boop boop, boop 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 beep boop, boop boop beep, boop boop boop, boop beep beep, boop beep boop, boop 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 boop, beep beep boop, boop boop boop, boop boop boop, boop. I don't know how far I am in this. Holy shit, this is long. Beep boop boop, boop beep boop, beep boop boop, boop boop boop, boop 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 boop, boop boop boop, boop beep boop, boop boop beep, boop 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 boop, beep beep beep, boop boop boop, boop boop beep, beep, boop boop boop, boop boop boop, beep, boop boop beep, boop boop boop, beep boop beep, boop boop boop, boop boop beep, boop beep boop, boop, boop boop boop, boop beep beep, boop boop boop, boop boop boop, boop, beep boop beep, boop boop boop, boop boop boop, boop boop boop, boop, boop beep boop, boop boop beep, boop boop boop, boop beep beep beep, beep boop boop, boop boop boop, boop beep boop, boop boop boop, boop, beep beep beep, beep boop, boop boop boop, boop, beep boop boop boop, boop boop beep, beep boop boop, beep boop boop, boop boop boop, boop, boop boop boop, boop boop beep, boop boop boop, beep boop boop, boop, beep boop boop, boop boop boop, boop boop boop, boop beep beep beep, boop boop boop, beep boop boop, beep boop boop, boop boop boop, beep, beep beep beep, boop boop boop, beep boop beep, boop beep boop, boop, boop boop boop, beep beep beep, boop boop boop, boop boop, beep boop, boop boop boop, boop boop boop, boop boop boop, boop boop, beep, boop boop, beep boop, boop beep boop. Hang on, I just said boop beep boop. The previous boop 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 I said before that was supposed to also be boop beep boop. Anyway, I'm here now. Boop boop boop, beep boop, boop boop boop, boop beep beep, boop boop boop, boop boop beep beep, boop boop boop, boop boop beep, beep boop boop, beep boop boop, boop boop boop, boop boop boop, beep, boop boop beep, boop boop beep, boop beep, boop boop boop, boop boop beep, beep beep boop, boop boop boop, boop boop boop, boop beep boop, boop, boop beep boop, beep boop boop, boop boop boop, beep boop beep, boop. This, oh my god, I'm having such trouble reading these. These are not looking like real words anymore. Oh my god. Beep boop boop, boop beep boop, boop beep boop, boop boop boop, boop, boop beep boop, beep boop boop, boop boop boop, boop boop boop, boop boop boop, boop, boop boop beep, boop boop boop, beep boop boop, boop beep boop, boop. It's looking like boat, boop, I don't know. Even these letters just look like they're changing into different letters. How close am I to the end? I'll scroll up and find my cursor. Oh, I'm so close. Okay, no big deal, no big deal. Where's my cursor? Okay, there we are. Beep beep boop, boop boop beep, boop beep beep, beep boop boop, boop, boop boop boop, boop beep boop, boop boop beep, beep boop boop, beep boop boop, boop boop boop, boop boop boop, boop boop boop, beep boop, boop beep, boop boop boop, beep boop beep, boop boop boop, boop. Boop beep boop, boop beep boop, boop boop boop, boop beep boop. Beep boop boop, boop boop boop, boop boop beep, boop 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 beep. Boop boop beep, beep boop boop. Boop boop beep, beep beep beep, boop. Boop boop beep beep beep, boop boop boop. Boop boop boop, boop. Boop boop boop, boop boop beep, boop boop boop, beep boop boop, boop. Beep boop beep, boop beep boop. And I can't read these anymore. I'm just like, I recognize them by the shape of the word, but they like don't look like they're spelled beep and boop. Like they look like they're backwards, or I don't know. I don't think I started this line yet, so I think I'm here. Beep boop beep, boop beep boop, boop boop boop, boop beep beep, boop boop, boop boop boop, boopy boop, boop boop beep boop, boopy boop, boop boop boop, boop boop beep, boopy boop boop, boop boop boop, boop boop boop, boop boop boop, beep boop boop, boop beep boop, boop boop beep, boop beep beep, boop boop boop, boop beep boop, beep boop boop, boop boop boop, boop beep boop, boop boop boop, boop boop boop, beep boop boop, beep boop boop boop, boop beep beep, beep boop boop boop, boop boop beep, boopy beep, boop boop boop, boop boop boop, boop beep, boop boop beep, boop boop beep beep, beep boop 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 beep, boop 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 boop, beep boop beep, boop beep boop boop, boop beep beep beep, boop boop boop. This looks like it says poll, P-O-A-L. What is up with that? I just said beep boop boop, right? So that means next is this. Boop boop boop, boop boop, beep boop boop, boop beep, beep beep boop, boop boop boop, boop boop boop, boop 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 boop, beep boop boop, boop beep boop, boop beep, beep boop boop. Now these are looking like they say loop. Boop boop boop, boopy boop boop, beepy boop, boop beep, boop beep boop, boop boop boop, beep boop beep, boop beep boop, boop boop, boopy beep, boop, boop boop, boop beep, beep boop, boop boop boop. I guess I wasn't actually as close to the end as I thought. Oh god, it's a ways off still. Okay, there I am. Boop boop, boopy boop, beep boop boop, boopy boop boop, beep boop boop, boop boop beep, boop boop boop, boop 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 boop, boopy boop, boop boop beep, boop boop boop, boop boop boop, boop boop, beep boop boop, beep boop boop, boop beep beep, boop beep, beep beep. I'm starting to think that writing this as triads would have been easier to read. Well, live and learn. Beepy boop, boopy boop, boop, boopy boop, boop boop boop, boop boop beep, beep boop boop, beep, boop boop boop, boop boop beep, boop beep boop, boop boop boop, beep, beep, boop boop boop, boop boop beep, boop boop boop, boop boop boop, beep, boop, 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 beep boop boop, boop boop beep, beep beep boop, boop beep boop, boop boop beep, boop boop boop, boop boop beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, boop, beep, 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 boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, beep, boop, beep, boop, beep, boop, boop, beep, boop, beep. That beep was supposed to be a boop. Beep, boop. Beep boop 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 beep boop boop beep boop 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 beep boop 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 boop. This looks like it is like louder. I'm so confused at this point. My eyes are just hurting, or my brain. I don't know which. Boop 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 beep boop 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 beep boop 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 beep beep. Boop, 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 beep, boop, 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 beep, beep, boop, boop, beep, beep, boop, beep, 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 boop, boop, beep, boop, 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 beep, boop, 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 beep, 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 boop, boop, beep, boop, 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 beep, beep, boop, boop, beep, boop, beep, beep, boop, beep, boop, boop, beep, beep, boop, boop, beep, boop, 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 beep, boop, boop. Boop, 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 beep. Boop, 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 beep. Somebody's saying boop is saying bope. Like B-O-A-P. I'm losing it. Boop, boop, beep. Beep, beep, beep. Boop, boop 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 beep beep boop 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 beep boop 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 beep boop beep boop beep boop boop beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop boop beep 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 boop beep boop 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 beep boop beep boop 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 beep beep boop 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 beep boop beep beep boop boop beep boop. My lips are starting to go numb. Like, you know, after you like mow the lawn and your hands are like tingly from the vibrations? That's what my lips feel like right now. Boop 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 beep boop boop beep 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 boop boop beep 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 boop beep beep boop beep boop 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 beep beep boop 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 beep boop 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 beep 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 boop boop beep boop 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 beep boop 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 beep boop beep boop 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 beep beep boop beep boop boop beep boop 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 beep 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 boop boop beep boop 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 beep boop 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 beep boop beep boop 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 beep beep beep. Where am I? I can't resist checking. Still a ways to go, but I'm getting there. Boop 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 beep boop 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 beep beep boop boop beep boop beep beep boop beep boop beep boop beep 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 boop 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 beep 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 boop boop beep boop 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 beep beep boop boop beep boop beep boop boop beep boop 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 beep beep boop 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 beep boop 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 boop. Looks like you're saying Boda now, B-O-D-A. Boop beep boop beep boop boop beep boop boop beep boop beep boop 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 beep boop beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop beep boop 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 beep boop 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 beep boop 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 beep boop boop beep beep boop boop beep boop 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 beep beep boop boop beep boop boop beep 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 boop boop beep boop 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 beep boop 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 beep 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 boop boop beep boop 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 beep boop beep boop 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 beep boop beep boop 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 beep boop boop beep boop boop beep boop beep boop boop beep boop boop beep boop beep boop 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 beep boop boop beep boop 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 beep boop 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 beep boop 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 beep boop 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 beep boop boop beep boop boop beep boop 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 beep beep boop boop beep boop boop beep 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 boop 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 beep boop 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 beep boop beep boop 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 beep boop 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 beep boop boop. I can see the end. Boop 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 beep boop 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 beep boop 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 beep boop beep boop beep boop beep boop boop beep boop boop beep boop beep boop 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 beep boop boop beep boop 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 beep boop 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 beep boop 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 beep boop beep boop beep boop boop beep boop 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 beep beep boop boop beep beep boop beep 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 boop boop beep boop beep boop 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 boop, 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 beep, boop, beep, boop, beep, boop, beep, boop, beep. That last beep was supposed to be a boop. Beep, boop, boop. Beep, boop, beep, boop, boop, boop. Beep, boop, boop, beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, 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 beep, boop, beep, beep, boop, 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 beep, boop, 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 beep, beep, boop, 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 beep, 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 boop, 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 boop. Boop beep boop 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 beep beep boop 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 beep boop 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 beep beep boop boop beep 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 boop boop beep boop 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 beep boop 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 beep boop beep beep beep. Oh my god. I'm done. I'm gonna check that my camera's still recording. Okay, good. It is. Yeah. So, because of the highly structured nature of the language, if I made a mistake in there, especially if I missed one of the phonemes, it just renders this whole thing utter nonsense. It's fault tolerant in some ways. Yeah, anyway, I also have this written down. The culture. So the etiquette's very important when conversing, because like you can make things unintelligible super easy. I probably missed a beep or a boop in there, and by the end of that, it just was making no sense because of that. And I definitely did not sound like a native speaker, or even a fluent speaker. So yeah, one of the biggest things when you're interrupting, keep the interruption as short as possible. And properly formatting instructions is critical, because if you never end the ML with 8 zeros, 8 boops, put the wrong number of bytes in a proper lexeme, format numbers wrong, that can just ruin the whole thing. Because there's variable length stuff and positional stuff. But anyway, that's it for literal Turing. It would be significantly easier and less cursed for humans to speak, and might actually be like a cool Conlang if we had like a lot more phonemes, so that it wasn't this insane, long, repetitive thing that's so hard. Like, those words were swimming together in front of my eyes. Boop was becoming like blope, bope, boat, bloated. Beep became peed at one point. It was bad. Maybe I have dyslexia. I don't know. But symbolic Turing. We'll just move on to that now. Really a way of calculating any arbitrary strings of ones and zeros. So you can mix it in with literal Turing anywhere. It still has beep and boop of literal Turing, and then I am not super great at IPA, so I'm not sure if I got this good here. So we have a modem screech phoneme. Onomatopoeia is this IPA, which is so glottal stop into I don't know what this letter is called in IPA, but harsh voice or vocal fry. We're saying that's forced vocal fry there. So I'm trying to say this is a fry screech. Okay. Then we have modem self-test tones, b and dong. This is the IPA I'm most confident on out of all the stuff in symbolic Turing. These I'm confident on because like they're easy. But then white noise phoneme, which is which I'm pretty sure this is right, and a downward sliding tone. This oh wait, is this supposed to be the squiggly line for fry? I don't know. Onomatopoeia here I tried to make this an onomatopoeia that's a downward sliding tone with different vowel shapes, and I think that squiggly line's actually fry, so this should be a squiggly line. And I did no. All right. Orthography 1 and 0, same as literal Turing. Modem screech phoneme is an open parenthesis. The white noise phoneme, close parenthesis. The modem self-test tones are / and a backslash. So I originally had it so that there was only one grapheme for the two modem self-test phonemes. That was just the / and odd numbered ones in a sequence would be ba, and even numbered ones in a sequence would be dong. So you get ba dong, ba dong. There's supposed to be a space there. And then the downward sliding tone is written as this. This has a funny Unicode name because it's not the combining character crossout. I think it might have been like a dentistry thing. It has a funny Unicode name, but I don't remember what it is. So exercise for the reader. Find that Unicode symbol because it has a funny name. Then, symbolic Turing, we break up into chunks, which are called machines. If you've ever heard of Turing machines, that's what these are. These are real things. Each machine tells you how to get a sequence of 1s and 0s, spelling out something in literal Turing. Starts with the open parenthesis, ends with closed parenthesis. So it starts with, ends with, and before we get into writing it, gotta step back. Look at what Turing machines are. So, state tables, any sequence of 1s and 0s, you can generate by, if you imagine an infinite sequence of zeros. Has a start, but no end. I know Turing machines are usually infinite in both directions, but this has a start in order to make some things easier. So we start at the beginning, we can step through and change some of these zeros to 1s, and then declaring that we've finished the end of our generated string of 1s and 0s, or beeps and boops, whatever. Where we end tells us the end of the string. So we can put a bunch of 1s in and then shift left, and those are all discarded. Just have the start to where we ended is the output. If you try to shift left and you're already at the beginning, has no effect. And then in order to step through it, we declare, God damn it. All right, hang on. Okay, none of these are incriminating. So I'm not gonna bother editing that out. But now we need to wait for it to load again. But I need to, it's because my scroll wheel has a rocker and I keep rocking it back and going back. But for the state table, let me fix the formatting like I had to do many times. Make these a little bigger so it's easier to read. There we go. So the list of states, we are always going to be in a state, and we just start with the first one we list. So state A, we're going to write a 1. So we're trying to write 1, 0, 1, 0. We're going to write a 1, step right, go to state B. This is when we get to the letter if it's a 0. So the first one is a 0. So we do this, write 1, step right, go to state B. Then the second one is a 0. And we have to write something, so we write 0. Things could just as easily be left undefined until you write a 1 or a 0, but we'll just say I'll start with zeros because that's nice, that looks nice. So we write a 0, step right, go to state C. State C. The third character is a 0, so we write 1, step right, state D. State D. The fourth character is a 0, so we write 0, step right, stop processing. And we are never going to find a 1 because we write 0. If we find a 1, like that would mean our initial state is wrong somehow. So it doesn't matter what these are. this is just garbage data. But in cases where you have more complex machines, this would not be garbage data. So it's not very complex, just steps left to right. So we start with the zeros, ellipses indicates it goes on forever. Right a 1, step right. Right a 0, step right. Or right a 1, step right. Right a 0. This is supposed to be 1. I don't know what I was thinking there. Right a 1, step right. Right a 0, step right. And there, that is our output, because beginning and where we stopped. If we then like stepped left 2, then this would be our entire string, just 1, 0, and these would be discarded. So to write the state table in symbolic Turing, we don't label individual states, because all the states have a defined structure, so we don't need to label them. They just all have an index that we can refer to. So we reference them by that index as a binary number that starts with b, or starts with b is 0 and dong is 1. We just have a binary number there. And then we write a 1 or a 0. That's just in there as a single bit. Step right or step left, it's a 1. And stop processing is this symbol. So state table above, translated, looks like this. You go beep boop dong, boop, beep dong, boop, boop, beep boop, no, not beep boop, badong, not badong, ba, dong, dong ba. Okay, and so on. So this is wrong. That is supposed to be a backslash, because we're going to this state. We're going to this state, and then it doesn't matter. This is also wrong. I don't have a state D in here. I should have a state D in here. So this is just going to write 101, not 1010. And we have the parentheses, and then it's beep boop bup boop beep boop boop dong ba boop beep beep boop boop beep. Yeah. Culture here has a bit more fluidity, subjectiveness than literal Turing does, because native speakers will create more complex machines that shift. They shift in both directions, overwrite stuff, and before creating the final output. So you do wordplay you have a machine that writes stuff, looks like it's going to be one thing, and then changes to another thing. So you have like an idea of what the literal Turing is going to be, but then it becomes different literal Turing before it's finalized. Then riddles, one form is you say a complex machine, and the listener, the person trying to figure out the riddle, tries to figure out if you ever stop processing. This is a real mathematical computer science problem called the halting problem. There is no way to know just by looking at or listening to the machine to know whether it ever stops processing in general. Some specific machines you can tell, but otherwise you just have to evaluate it till you get bored, and it either you realize you've gotten stuck in a loop, you realize you got stuck in some other pattern that's not a loop but will cause it to never end, like never stop shifting right, or. if it's something more complex than that, that causes it to never halt, unless you realize that it never halts by trying to evaluate it, by stepping through it, you have to wait. You might just have to wait until you get bored or until it halts. Halts means stop processing. Yeah, so that's how I tied the halting problem to conlangs, which I'm pretty proud of myself for. But anyway, a simple riddle that you could use to fool young children, perhaps, is you just don't include the stop processing grapheme or phoneme or whatever. So, like, I'm not going to do the actual phonemes, I'm just going to read the English names for the characters. Left parenthesis, 10 /00 /11 \/01 \/01. That just goes back and forth, swapping ones and zeros, and never ends. And it might take a young child a while to figure that out if they're processing it. So you can see how you can get started with simple riddles and work up to very, very complex riddles. In fact, I think you can make, if I remember correctly, from how the Busy Beaver problem works. Look up Busy Beaver. It's insane. Busy Beaver computer science concept. It's insane. I think once you get to like 5 states, maybe, or maybe it was 7. Definitely by 10. It is possible to make machines that, as humanity, like all of humanity working on this, has not been able to figure out if every machine of this length stops processing. So there could be some machines that are too difficult to figure out, and it can just go as an unsolved riddle in Turing culture. It may not be quite accurate because those machines extend infinitely to the left also. So how many possible states it takes before it gets uncomputable might be different for machines in symbolic Turing here. So example, we'll take our literal Turing, the movie script, and expand it into a simple machine that just writes things out left to right. A native speaker would do a better job of it. Now this is about 150 pages, it looks like. I am not going to read all this. I think something might be wrong here. I don't know why there are nouns. And oh, no, that's why. Because it ends here. Not that many pages of it. We are on, oh good. This takes up like 30 pages, so it's still like 135 pages of human readable phonetic spelling that I'm not going to read out. As the time of recording, I am undecided whether I am going to get an AI voice generator or something to read it out. I don't know. But yeah, and that is the end of the Turing Conlang. The last thing I'm going to show you is the second web page I made to assist. This is much, much simpler. All I'm doing is taking ones and zeros and mapping it to the necessary stuff to to be I'm losing focus. I'm losing my train of thought. It maps it to the necessary stuff to be symbolic Turing. Now, Here's what that one looks like. I didn't bother doing the stylization, but you can see it does some interesting patterns, and yeah, look how it shifts for like wrapping different lengths. I think that's pretty cool. But what was even cooler is the fact that, so this is 8 kilobytes if I remember correctly. So it's long, it's pretty long. But originally, the bedongs that are binary numbers, remember how earlier I said it was odd numbered ones were going to be ba, and even numbered ones were going to be dong. It was going to be single grapheme. That's because I was going to use base 1 for it. Now the thing with base 1 is numbers get really long, really fast, because it is just like tallies. It's the number of digits is the number. So that was 44 megabytes of output before it was even translated into a phonetic thing that a human would be able to read, when it was just like this stuff. So like I had to change it. But that other way was more cursed, and this output here that you're seeing, when that's base 1, I'm gonna find the screenshot I took of it and put it up. It looks like the graph of Busy Beaver computation. Hang on, let me get the Wikipedia article up so I can show you what I mean. It looks like this. I'm gonna find the image and show it to you so you can compare. This is what a 5-state Busy Beaver looks like. So this is a this would be equivalent to one of those machines that only has 5 rows. These are the first 100,000 time steps, and these are showing like different branching paths to determine if it halts. I think maybe. No, this is showing the state of the machine. I don't know. I don't quite understand this graph. I can barely wrap my head around Busy Beaver. It's a wild concept, but I thought it was cool that this looks like the output of my Conlang. And like, I know there are, I don't know, let me click on the image, see what it's named. So go to more details. Let's go to the Wikimedia page. 5, 6, okay. Yeah, thanks. Harry's doing Mathematica. Okay, give appropriate credit. Okay, yeah, look at who made it. Ordinary Artery, you have a better understanding of computer science than I do, or at least to the Busy Beaver stuff. I am free to copy, distribute, and transmit it, which I'm doing. I'm not adapting it. Attribution, I must give appropriate credit, provide a link to the license, and indicate if changes were made. Not making changes. The licensor does not endorse this use. I guess I have to say that. And the, I guess every frame of this video where this is used is distributed under the same license. Creative Commons Attribution, share alike 4.0. Yeah, so here's the license here. This is my due diligence of showing you the license. Every frame of the video that has this in it is under this license. The rest of the video and all the audio is public domain because I don't believe in copyrighting things. But that's not relevant to the Conlang. I'm going to say this again. I think it's cool that this Conlang ended up tying into Busy Beaver concepts in not just one but multiple ways. And definitely look up more on Busy Beaver. There's a very popular YouTube video that I forget the name of the channel. Is it Mutual Information? It might be Mutual Information. But I'm going to leave a link in the description because it is two videos actually. They're great descriptions of Busy Beaver that accurately describe how wild it is and how cool it is and help you start to wrap your head around it. But that is my Conlang. I'm either going to be entering this in 2023 if I fall within the wiggle room that mentioned, or if not, then this will be for 2024 Agma Schwa's Cursed Conlang Circus. I had a fun time making this. I did not have a fun time reading the translated literal Turing, and I didn't even read the symbolic Turing. I'm just going to have an AI generate that, but yeah. I hope you have a great rest of your day. Bye.
Squeak boop boop bat boop boop neo boop boop dong boop boop neo beep boop dong bat boop boop neo beep boop dong dong boop boop neo. Boop boop dong bat bat boop boop neo boop boop dong bat dong boop boop neo boop boop dong dong bat boop boop neo beep boop dong dong dong. Boop boop neo boop boop dong bat 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 boop boop neo boop boop dong bat bat dong boop boop neo boop boop dong bat dong bat boop boop neo. Beep boop dong bat dong dong boop boop neo boop boop dong dong bat bat boop boop neo boop boop dong dong bat dong boop boop neo boop boop. Dong 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 bat boop boop neo beep boop dong 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 boop boop neo boop boop dong bat 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 boop boop neo boop boop dong bat. Bat bat dong boop boop neo boop boop dong bat bat dong bat boop boop neo boop boop dong bat bat dong dong boop boop neo boop boop dong bat. Dong bat bat boop boop neo boop boop dong bat dong bat dong boop boop neo boop boop dong bat dong dong bat boop boop neo beep boop dong bat. Dong 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 boop boop neo boop boop dong dong bat 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 boop boop neo boop boop dong dong bat bat dong boop boop neo boop boop dong dong. Bat dong bat boop boop neo beep boop dong dong bat dong dong boop boop neo boop boop dong 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 bat bat boop boop neo boop boop dong dong. Dong bat dong boop boop neo beep boop dong 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 bat boop boop neo beep boop dong 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 boop boop neo boop boop dong. Bat 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 boop boop neo boop boop dong bat 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 dong boop boop neo boop boop dong bat 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 dong bat boop boop neo beep. Boop dong bat 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 dong dong boop boop neo boop boop dong bat bat dong bat bat boop boop neo beep boop dong bat bat dong bat dong boop boop. Neo boop boop dong bat bat dong dong bat boop boop neo boop boop dong bat bat dong 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 boop boop neo boop boop dong bat dong bat bat. Bat boop boop neo boop boop dong bat dong bat bat dong boop boop neo boop boop dong bat dong bat dong bat boop boop neo boop boop dong bat. Dong bat dong dong boop boop neo boop boop dong bat dong dong bat bat boop boop neo boop boop dong bat dong dong bat dong boop boop neo boop. Boop dong bat dong 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 bat boop boop neo beep boop dong bat dong 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 boop boop neo boop boop dong dong bat 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 boop. Boop neo boop boop dong dong bat 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 dong boop boop neo boop boop dong dong bat bat dong bat boop boop neo beep boop dong dong bat bat. Dong dong boop boop neo boop boop dong dong bat dong bat bat boop boop neo beep boop dong dong bat dong bat dong boop boop neo boop boop dong. Dong bat dong dong bat boop boop neo boop boop dong dong bat dong 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 boop boop neo boop boop dong 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 bat 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 boop boop neo. Boop boop dong 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 bat bat dong boop boop neo boop boop dong 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 bat dong bat boop boop neo boop boop dong 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 bat dong dong. Boop boop neo boop boop dong 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 bat bat boop boop neo beep boop dong 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 bat dong boop boop neo boop boop dong dong. Dong 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 bat boop boop neo beep boop dong 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 boop boop neo boop boop dong bat 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 boop boop neo. Boop boop dong bat 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 dong boop boop neo boop boop dong bat 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 dong bat boop boop neo boop boop dong bat 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 dong. Dong boop boop neo boop boop dong bat 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 dong bat bat boop boop neo boop boop dong bat 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 dong bat dong boop boop neo boop boop. Dong bat 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 dong dong bat boop boop neo boop boop dong bat 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 dong 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 boop boop neo boop boop dong bat bat dong bat bat bat. Boop boop neo boop boop dong bat bat dong bat bat dong boop boop neo boop boop dong bat bat dong bat dong bat boop boop neo beep boop dong. Bat bat dong dong boop boop neo boop boop dong bat bat dong dong bat bat boop boop neo boop boop dong bat bat dong dong bat dong boop. Boop neo boop boop dong bat bat dong dong bat boop boop neo beep boop dong bat bat dong dong boop boop neo boop boop dong bat. Dong bat 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 boop boop neo boop boop dong bat dong bat bat dong boop boop neo boop boop dong bat dong bat dong bat boop boop. Neo boop boop dong bat dong boop boop neo boop boop dong bat dong bat boop boop neo boop boop dong bat dong. Bat dong boop boop neo beep boop dong bat dong boop boop neo beep boop dong bat dong bat boop boop neo beep boop dong bat dong boop boop neo boop boop dong bat dong boop boop. Neo boop boop dong dong boop boop neo boop boop dong bat dong boop boop neo boop boop dong bat dong. Dong boop boop neo boop boop dong bat dong boop boop neo beep boop dong bat dong bat boop boop. Neo boop boop dong boop boop neo beep boop dong bat dong bat boop boop neo beep boop dong bat dong. Dong boop boop neo boop boop dong boop boop neo boop boop dong bat boop boop. Neo boop boop dong boop boop neo boop boop dong boop boop neo beep boop dong bat. Bat dong boop boop neo beep boop dong boop boop neo beep boop dong bat dong boop boop. Neo boop boop dong boop boop neo boop boop dong boop boop neo boop boop dong bat. Dong boop boop neo boop boop dong boop boop neo boop boop dong bat dong boop boop. Neo beep boop dong boop boop neo beep boop dong boop boop neo beep boop dong bat. Dong boop boop neo beep boop dong boop boop neo boop boop dong boop boop. Neo boop boop dong boop boop neo boop boop dong boop boop neo beep boop dong dong. Bat dong boop boop neo boop boop dong boop boop neo beep boop dong dong bat dong boop boop. Neo beep boop dong boop boop neo beep boop dong boop boop neo beep boop dong dong bat dong boop boop neo boop dong dong. dong 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 ba dong ba ba boop boop neo boop boop dong 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 ba dong ba dong boop boop neo beep boop dong 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 ba dong dong ba boop boop neo boop boop dong 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 ba dong 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 boop boop neo boop boop dong 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 ba 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 boop boop neo boop boop dong 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 ba ba dong boop boop neo boop boop dong 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 ba dong ba boop boop neo boop boop dong 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 ba dong dong boop boop neo boop boop dong 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 ba boop boop neo beep boop dong 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 ba dong boop boop neo boop boop dong 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 ba boop boop neo beep boop dong 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 boop boop neo boop boop dong ba 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 boop boop neo boop boop dong ba 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 dong boop boop neo boop boop dong ba 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 dong ba boop boop neo boop boop dong ba 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 dong dong boop boop neo boop boop dong ba 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 dong ba boop boop neo boop boop dong ba 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 dong ba dong boop boop neo boop boop dong ba 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 dong dong ba boop boop neo boop boop dong ba 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 dong 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 boop boop neo boop boop dong ba 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 dong ba ba boop boop neo boop boop dong ba 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 dong ba dong boop boop neo boop boop dong ba 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 dong ba dong ba boop boop neo beep boop dong ba 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 dong ba dong dong boop boop neo boop boop dong ba 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 dong dong ba boop boop neo boop boop dong ba 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 dong dong ba dong boop boop neo boop boop dong ba 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 dong 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 ba boop boop neo beep boop dong ba 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 dong 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 boop boop neo boop boop dong ba 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 dong ba 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 boop boop neo boop boop dong ba 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 dong ba ba dong boop boop neo boop boop dong ba 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 dong ba ba dong ba boop boop neo boop boop dong ba 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 dong ba dong dong boop boop neo beep boop dong ba 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 dong ba dong ba boop boop neo boop boop dong ba 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 dong ba dong ba dong boop boop neo beep boop dong ba 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 dong ba dong dong ba boop boop neo boop boop dong ba 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 dong ba dong 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 boop boop neo boop boop dong ba 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 dong dong ba ba boop boop neo boop boop dong ba 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 dong dong ba dong boop boop neo boop boop dong ba 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 dong dong ba dong ba boop boop neo beep boop dong ba 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 dong dong ba dong dong boop boop neo boop boop dong ba 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 dong 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 ba boop boop neo beep boop dong ba 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 dong 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 ba dong boop boop neo beep boop dong ba 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 dong 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 ba boop boop neo beep boop dong ba 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 dong 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 boop boop neo boop boop dong ba 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 dong ba 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 boop boop neo boop boop dong ba 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 dong ba 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 dong boop boop neo boop boop dong ba 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 dong ba ba dong ba boop boop neo boop boop dong ba 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 dong ba ba dong dong boop boop neo beep boop dong ba 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 dong ba ba dong ba boop boop neo boop boop dong ba 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 dong ba ba dong ba dong boop boop neo boop boop dong ba 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 dong ba ba dong dong ba boop boop neo beep boop dong ba 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 dong ba ba dong 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 boop boop neo boop boop dong ba 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 dong ba dong ba ba boop boop neo boop boop dong ba ba dong ba dong ba dong boop boop neo boop boop dong ba 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 dong ba dong ba dong ba boop boop neo boop boop dong ba ba dong ba dong ba dong dong boop boop neo beep boop dong ba 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 dong ba dong dong ba boop boop neo beep boop dong ba ba dong ba dong dong ba dong boop boop neo beep boop dong ba 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 dong ba dong 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 ba boop boop neo boop boop dong ba ba dong ba dong 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 boop boop neo boop boop dong ba 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 dong dong ba ba boop boop neo boop boop dong ba ba dong dong ba dong boop boop neo boop boop dong ba ba dong dong ba dong ba boop boop neo boop boop dong ba ba dong dong ba dong dong boop boop neo boop boop dong ba ba dong dong ba dong ba boop boop neo beep boop dong ba ba dong dong ba dong boop boop neo beep boop dong ba ba dong dong ba dong dong ba boop boop neo beep boop dong ba ba dong dong ba dong 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 boop boop neo boop boop dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong dong ba dong boop boop neo boop boop dong ba ba dong dong ba dong ba boop boop neo boop boop dong ba ba dong dong ba dong dong boop boop neo boop boop dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong dong ba dong boop boop neo boop boop dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong dong ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong boop boop neo boop boop dong ba ba dong ba dong ba boop boop neo beep boop dong ba ba dong ba dong dong boop boop neo boop boop dong ba ba dong ba dong ba boop boop neo boop boop dong ba ba dong ba dong ba dong boop boop neo boop boop dong ba ba dong ba dong dong ba boop boop neo beep boop dong ba ba dong ba dong dong boop boop neo boop boop dong ba ba dong ba dong ba boop boop neo boop boop dong ba ba dong ba dong boop boop neo boop boop dong ba ba dong ba dong ba dong ba boop boop neo boop boop dong ba ba dong dong boop boop neo beep boop dong ba ba dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong dong boop boop neo beep boop dong ba ba dong 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 ba boop boop neo beep boop dong ba ba dong dong boop boop neo boop boop dong ba ba dong ba dong ba ba boop boop neo boop boop dong ba ba dong dong boop boop neo boop boop dong ba ba dong ba dong ba dong ba boop boop neo beep boop dong ba ba dong dong boop boop neo boop boop dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong dong boop boop neo beep boop dong ba ba dong dong ba boop boop neo beep boop dong ba ba dong dong boop boop neo boop boop dong ba ba dong dong ba ba boop boop neo boop boop dong ba ba dong boop boop neo boop boop dong ba ba dong dong ba boop boop neo boop boop dong ba ba dong boop boop neo beep boop dong ba ba dong dong ba boop boop neo beep boop dong ba ba dong boop boop neo boop boop dong ba ba dong dong ba boop neo beep boop dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo beep boop dong ba ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong ba dong boop boop neo beep boop dong ba ba dong ba boop boop neo beep boop dong ba ba dong ba dong ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong boop boop neo beep boop dong ba ba dong ba boop boop neo beep boop dong ba ba dong ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong boop boop neo boop boop dong ba ba dong ba boop boop neo boop boop dong ba ba dong boop boop neo boop boop dong ba dong boop boop neo boop boop dong ba dong boop boop neo boop boop dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo boop boop dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop neo beep boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop neo boop boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo boop boop dong ba dong ba dong boop boop neo beep boop dong ba dong ba dong boop boop neo dong ba dong ba dong boop boop neo boop boop dong ba dong boop boop neo boop boop dong ba dong boop neo boop boop dong ba dong Patang Thank
Jesus fucking Christ.